We wouldn't be where we are at Google without you, the developer community. Since 2005, we've made dozens of APIs and tools available to you. Then you went out and built marvels. Now, with so many creations, we think there's a better way for them to work together, because there are a lot. So we did some spring cleaning, then asked you how we could do it better. We used your ideas to begin building a single place for all of the developer resources, tools, events, and community. And all that together looks like this. developers.google.com. But it's more than just a logo. It's a symbol for all the amazing work you do in the world, and how you work together. Soon you can find tools, get ideas, and connect with others, all in one place. Then get down to business. Collaboration and coding power that creates magical solutions with a universal language, so you can take that massive code and blow minds. For reals. So kick off your shoes and explore all the ways you can connect. Because it's not just about code, it's about you. Then start building. Because together, there's no telling what we'll create next. developers.google.com.
Hello, and thank you for coming to our lightning talks today. I just have a couple things to say as we get started. We have this agenda for you. So we're going to start out with Android, go through the whole gamut, and end up at maps. And one thing I wanted to mention before we got started is that there is a whole bunch of Google stuff going on today. So we've got the lightning talks today, but we have all these other houses going on with maps and developers and Android. And I really recommend you check out all of these things. And if you forget this map, a lot of us are wearing these sweatshirts. And it won't be creepy. Just come up and look at where you need to go. There's also this URL that'll give you the map and all the other talks that are going on by Googlers or at the Google developer houses. Thank you so much. And I'd like to welcome up Trevor, who's going to begin by talking about Android, what Android apps should look like, and where you can go to build them.
All right. Hi, everyone. My name is Trevor Johns, and I'm a developer programs engineer with the Android team at Google. And today, I'm going to be talking about Android user interface design, and specifically what we've done with the last few releases of Android with the Holo UI. So we're going to start out to give you a brief tour of where we've gone in the past, how Android's evolved, the changes we've made, why we've made them, and what they mean to you as an Android app developer. So let's go ahead and step in our time machine here, and we're going to roll all the way back to Android 1.5, Cupcake. So for those of you who are keeping score, this was released roughly in the era of the G1, one of our first back in 2009. Technically, it wasn't our first release. That was Android 1.0, but it looked pretty much the same. And if you're using Android today, it should be familiar. You have your app launcher, you have your icon drawer, and we opened up a settings app here just as a demo. And you can see that there's this little drawer you had to pull up manually. We have this big bulky search widget on the desktop. The settings app, you sort of get this sort of ugly wall of text with these down chevrons that go somewhere down. I'm not sure what down means. And that was Android. Sort of a rough start, but we'll get there. So let's move forward one version. This is Donut now, released just a short time later. And not much has actually changed. We've gone and cleaned up that big bulky search widget. It's a little more streamlined now, but not too many other changes there that are really notable, at least as far as the UI is concerned. So then we're going to take one more step forward to Android 2.0. That's Eclair. And this release is notable because this is the one that came out with the Motorola Droid. We did a lot of work to go and clean up the UI here, so icons are a little bit more streamlined. The settings app is actually not a giant wall of text. We've gotten rid of those confusing chevrons. The app launcher is still more or less the same thing, though. You have the store you pull up manually, some carbon fiber texture there in the background. And that was what we released there with the Droid. Take one more step forward here and get to Froyo version 2.2. And this one is probably where you see the most changes. We've actually gone and removed that drawer that you actually had to go and swipe up with a app launcher button, added a set of quick actions there at the bottom to go and pull up the phone and the browser, which are pretty common actions on a smartphone. And we added system-wide search. So you'll notice that search widget's changed just a little bit too. Settings app still looks more or less the same. You still have this gray bar at the top of this app name. Navigation hasn't changed much. And but that was probably to date the biggest change to the Android UI we've seen. And then one last step forward, which was Android 2.3, Gingerbread. And you'll notice the biggest change here is we sort of made the UI a little bit darker. With this little widget we added on desktop to sort of give you a tutorial has changed, just slightly made it a little darker. The quick launch or the quick actions at the bottom have changed. The notification bars changed. Still the same settings app, still the same launcher pretty much. And so that was our previously release of Android. That's where we've come to up until fairly recently. So when we were building Honeycomb, we took a step back and said, well, we've had the same look since the beginning. What can we change? There's a lot of wasted screen real estate with buttons, a lot of space taken up by these big, bulky text fields. And it sort of felt inspired by a desktop OS. And you have this magical pane of glass in front of you. And there's so much more you can do. It can be this tactile experience. You can go and get rid of all these desktop metaphors and sort of come up with a brand new experience. And like I said, we haven't really changed that much. There was that change with 1.5, but it was more of an incremental change. It wasn't really revolutionary. We also noticed that there's a lot of inconsistency. Android, of course, allows device manufacturers to go and modify the OS to go and add some distinctiveness to it. But what the feedback we heard from a lot of designers was, if you go and change the text color, if you change the selection color, if you change the way a list view behaves, or the way overscroller works, and you're really going for that picture-perfect UI, when these things change out from under you, it makes it hard to go and make your app look beautiful. So we took all this feedback, and we put it together, and we got what we call Holo, or holographic UI. So going back to 2.3 here, let's take one more step forward, and this is the face of Android today. Still the same metaphors you're sort of familiar with as far as having an app launcher, right? I mean, there hasn't been that much of a change there. But the bigger changes are a little more subtle. If you look at the search widget, you'll notice it's a lot more minimalist. We've added these blue futuristic highlights everywhere. Organized the settings app finally, so that actually makes a little bit more sense to scroll through. And then there's also this space at the top of the screen that's reserved for what we call the action bar. And we'll go into that in a bit more detail, but that's actually pretty important. So this is Holo, one release for all devices, whether or not it's a tablet or a phone. And we really have gone through and we've taken a look at everything in the phone, whether or not it's how a dialog appears, how a list view behaves, how you scroll through your media, and asked ourselves what assumptions we've been making for this design. And this goes all the way down to the widget toolkit. So this is the selection of all the or I think most of the controls that come with the SDK. Of course, you can add more. The big one there is probably the text view, or the text input fields, and you can actually barely see them on the screen. It's sort of up there in the upper right, and it's actually just a line. And I'll show you a screenshot of that in a moment. But actually, let's go right there and right now. So on the left is the email app in Gingerbread, and on the right is the email app in Honeycomb and Ice Cream Sandwich. And you'll notice we really just reduced it to a sheet of paper. Of course, you still need your text fields to go and tell it, address the email, give it a subject, actually compose. But the UI sort of fades into the background and brings your content front and center so that the users can focus on their creativity and not on what their phone is trying to impose as far as the UI is concerned. So we basically have 3 design principles that underline Holo. And we wanted a UI that felt enchanting, that simplified users' lives, and that made them feel amazing and empowered because of that. So let's talk about those in a little bit more detail. I'll give you a quick tour through some of the design highlights here. We wanted it to be delightful. There's lots of visual flourishes sprinkled throughout the OS. When you're scrolling left or right on the home screen and you hit one end of the screen, this pane of light will sort of pop out from the screen for just a second. It's a very subtle effect. But it gives your phone a bit of personality, makes it feel a bit more fun, makes it feel like it has a bit more substance, than you're actually working with this physical interface inside of the phone. Sort of extending from that idea of a physical interface, objects behave as actual objects rather than buttons. If you have an icon and you drop it on top of another icon, what do you expect should happen? They should stack. Well, that's exactly what happens. And so little things like that are found all throughout the OS. Personalization has always been an important part of Android. It still is. We want the user to feel like their phone belongs to them. So of course, that it starts with things like setting your background, being able to go and adjust the behavior of your phone, add widgets everywhere, make the phone yours. On the other hand, the phone will get to know you and personalize itself automatically. So as you're browsing around the web and say you go and visit Wikipedia a lot, your phone will of course save that in its local history, and then later on when you go and try and do a system-wide search, it'll check that history and start adding autocomplete suggestions for Wikipedia, even though you're not in the browser. So the next topic there, simplifying your life. All right, this is, actually let's move to the next screen here. So first things first, we want to go and keep the dialogues nice and simple, wizards nice and simple. When you first turn your phone on, we have this initial setup process. So as an example here, one of the screens asks you to go and set up a Google account. And we keep the text there very brief, and when you actually go to sign up for the account, it's just a one-page form you fill out. Just as an example there. But throughout the system, we've gone and reevaluated all of our dialogues, tried to figure out where we were being too verbose, not saying enough, and kept it basically the bare minimum we could while still being informative. Pictures and these graphical UIs are a big part of Holo. We sort of call this like a magazine UI, so big, high-resolution, vibrant pictures right there in front of your screen. And so this is the dialer app. When you launched the dialer app in the past, it used to give you this whole list view of contacts, and you could scroll through, and eventually you'd find who you're looking through. You could star people, add them to this quick list. But we found that it's a lot quicker if you just have a picture right there. If I want to call Matthias and I open my phone, well, there he is in the upper left-hand corner. I can just click on him. I don't have to actually go through and read everything. And so pictures are a lot faster than words. We try and use these high-resolution images throughout the UI whenever we can. We also try and do the right thing automatically. So we've added a feature in Android 4 Ice Cream Sandwich called Android Beam. And when you take two phones and you hold them next to each other, if they have an NFC antenna, they'll detect that the other phone is in proximity and enter this share mode. You can then go and tap on whatever content on your screen is on your screen, and it'll send it over to the other phone. So we're using this context sensitivity to go and just automatically throw the user into the share mode so that the action they most likely want to perform, since they've put their phone next to another phone, is just one tap away. Of course, you still don't want to leave that final action to the user and not do everything for them, but just get them into the right position so that they're ready to do that. Navigation is, of course, important. We've always had this concept of a back button on Android. We've gone and extended that a bit more with the action bar. I'll go into that in a bit more detail in a moment here. Also, we've gone and taken the most commonly used actions and pulled them out of the menu bar. In fact, the menu bar is pretty much deprecated at this point. If you target your app for Android 3 or above, so anywhere running Holo, we actually remove the menu button from the screen and place all of the old menu commands up in this action bar. And as a developer, you can pick whether or not something should be displayed right there one click away at the top of the action bar, or we still do have an overflow menu where you can hide the less commonly used actions. But the really important actions should be right there, one click away at all time, and your phone should go and adjust its UI to what you're doing so that those are always there. And I'll give you some more examples of that in a moment. Also going off of navigation, consistency is important. The action bar that we've added does a lot towards that. So we have examples here from Maps, Inbox, and the Gallery app. And you'll notice that even though they are very different apps, they look different. A map view looks a lot different than a gallery view, looks a lot different than your email. The navigation looks the same in all of those, and that's intentional. And we provided the tools to go and do that for app developers anywhere in the system. And if you are a long-time Android user, notifications are, of course, a very important part of that experience. We've had that since the beginning. But just to go and reiterate, we want to go and make sure that whenever there's an important event that occurs, of course you do since it's important, you want to let the user know. But make sure that you only interrupt them if it's important. And if it's not important, it's sort of we go and tuck it away so that users can respond to that notification later. So we bring things up, give them a chance to respond, and then let them deal with things on their own time. So you don't get any big, bulky dialogues that come up and stop the user from what they're trying to do. All right? So on this last part about empowering the user and making them feel amazing, we've added lots of gestures throughout the system that let you go and basically they're tricks that let the user pull something off and with some gesture, some action, and do it without having to push a button. We're trying to remove as many buttons from the UI as we can. And gestures are always a little tricky because you can put up a little tooltip and tell them, but most of the time they're not pushing something that's labeled there. So once you go and perform some gesture, we want to make sure that it works throughout the system. Once you've learned in Gmail that you can swipe left and right between your email messages, you'll discover, oh, you can do the same thing in Google Play and swipe left and right between categories in the App Store. You can also go into the Google Plus app and do the same thing and switch between your own circles and people nearby. Dialogues, we've gone and cleaned those up again, made sure that they're actually useful rather than just saying that there's an error that's occurred and taking you onto the support page. We try and give you the text you need to make sure that you can respond to it and actually resolve the situation. There's little bits of visual encouragement sprinkled throughout the system. So as you're going and dragging icons around, we overlay this grid and put this little shadow of the icon that sort of jumps around as you drag your icons around. So even if you've never used an Android device before, you'll immediately know that these devices are going to go and snap to a grid. And finally, this is less of a UI issue and more of a functionality issue, but apps should be smart. And they should do the heavy lifting for the user. If you have a smartphone in your pocket, it should be smart, right? So it's little things. If you're in the camera app, you should automatically adjust white balance. You should automatically set focal points. Sure, give the users a way to go and set it if they want, but by default, you should just go and do everything automatically. Which also gets to the next point here, which is you should make the important things fast. Again, if you're in the camera app, the most important thing is taking a picture. If you press that shutter button, you should take a picture immediately. So we've even gone so far as to go and add 0-second shutter lag. So the moment you press that button, the photo is immediately saved to disk, and there's no delay while you're waiting for the shutter to fire and for it to find the focal point. It's instant. So as an Android app developer, what does all this mean to you? So we've gone and put together a collection of design patterns that you can use. And the most important one, if you haven't heard me mention it a dozen times already, is the action bar. This is roughly 50 pixels, I can't remember the exact number, of space at the top of your screen that's reserved for the most important navigational elements. And it's broken up into three sections. So you have an app icon, which tells you where you are. Typically, this is going to be your own application's icon, but you can change it if you're in a document, make it look like your doc, things like that. You have view details, so this is things like navigational tabs. And then you have your action buttons, which tell the user what they can do. And this can either be the overflow menu where you put the less commonly used actions, the actual, like I said, you can bring those actions front and center, just place them there. You can even add custom views, things like search widgets. Basically, anything the user wants to do commonly should be part of that action bar. It's also contextual. So as you start making selections, we actually will swap that action bar out, flip it around, and give you a completely different set of commands. If you're in email, normally the first thing you'd want to do is compose a new message. But once you start selecting messages, it's not likely that that's what you want to do anymore. Most likely what you want to do is something related to organization. You're going to want to archive your messages, or you're going to want to go and maybe mass delete them if they're all spam, heaven forbid. As soon as you go and enter this different mode, the phone will go and adapt and place you in the right context for whatever it is that you're most likely going to want to do. Navigation, I mentioned that there is this, this back button, and then we've added an additional back command up to the action bar. So the back button, which has been there since the beginning, provides temporal back navigation. So if I'm in my web browser and I click a link that takes me into the Google Play Store, when I click back, it's going to take me back into the browser, because that's the last thing I did as far as my sequence of events on the phone. But what we discovered is sometimes users actually want to go and, once they navigate into that other app, they want to go and explore more there. They want to get back to the home page of that app. And so the other back button is a hierarchical back button. It'll take you back up within the navigational tree of the current application. So we actually call it up. So that's actually, if you think of a tree, you're going back up to the root of that tree. So if I'm in Google Play and I'm in an app detail page and I click up, it'll start taking me back to the home, the Google Play main screen. And so that's a really important navigational pattern that you'll find all throughout Android now, and it's really important to go and make sure your apps are updated to go and follow that. Multi-pane layouts are important because, again, we have one release of Android for tablets and phones. So this is sort of a pattern people have been using in mobile apps since the beginning. You have, say, your contacts app. You have this table of contents that lists all of your contacts. You click on somebody, and it'll take you into a detail view. So what we've done is we've broken that up into what we call fragments. So you can go and lay them out side by side. So now, same views. You still have the table of contents on the left. You still have your details on the right. But you can go and stack them and rearrange them. And so this does two things. One is a really intuitive way to go and work with the device as a user. And as an app developer, it allows you to reuse your code. It's actually the exact same code laying out that table of contents and displaying that detail view. We're just going and running both of them simultaneously. And there's a lot of options to go and rearrange things too. So you can go and, of course, place them side by side like I did in that example. Or you can go and stack them on the right, stack them on the bottom, have things slide in and out. We've added commands to go and do animation. So there's a lot of different ways to go and compose your UI and make something that looks really beautiful. And as an app designer, it's up to you to figure out what works. We've given you the tools to make sure that you can do it. I mentioned gestures already. Gestures are really important. We want to make sure that your device feels like an actual environment the user's interacting with. So we've actually documented a whole set of common gestures, things app developers will want to go and integrate into their app. Things like double tapping to go and zoom in. Being able to go and swipe left and right to go and move between pages. And actually, that's what my next slide will talk about a little bit more too. Drag and drop. We've added a lot more APIs to go and let you go and take care of drag and drop and move data between different fragments. Swipe views. Like I said, you want to make sure that you can go and page through the different parts of your app. We've added a class to our API called ViewPager that makes this really easy. And one last thing to talk about here is make sure your app feels like a pure Android app. So I've taken a collection here of UI elements from different mobile OSs. And functionally, they're all the same. Button is a button, a checkbox is a checkbox, a text field is a text field. But visually, they look completely different. And if you're porting your app over from one environment to another, and you use the visual elements from that other environment, not only is it going to make your app just look wrong, it's going to confuse users too, because on other environments, they actually do have subtle differences in behavior. And this is not just about making sure your buttons look the same, but the way things behave and the way things are laid out. So to give you a few examples here, we have the dialer app. And when you're in the dialer app on the Android, you'll notice that there's again, that action bar at the top that contains your navigation. On the right here, we have the dialer app from iOS, and that tab bar is at the bottom. And you never have a tab bar at the bottom of on an Android app, but yet we see app developers go and make that mistake. To give you a couple other examples here, back commands that are actually labeled, you'll never do. It's always that up command. And when you're in a list view, you should never have right-facing chevrons. When you're in a list view, it should be obvious you're in a list view. Remember that screenshot I showed of Android 1.5 where we had all those really confusing chevrons? Of course, those pointed down, and I have no clue where down goes. But is that really any different than right? We don't actually, when you click on something on Android, it doesn't slide out of the way. It just jumps into that next screen. So a right-facing chevron doesn't make any more sense. So we've taken all of these tips and even more, and we've put them on a site that we call Android Design. And we just launched it a few weeks ago. And we've put together a lot of resources for you as app designers, whether or not it's UI stencils for Photoshop, and all of the design philosophy and design patterns that I've mentioned, put them up there for you as well. Basically so that you can figure out everything that we were thinking when we were developing the OS, that you can apply those to your app. So if there's one thing that you take out of this talk today, it's this URL here, developer.android.com/design. Go there, read through it all, internalize it, and do what we did with Honeycomb, an ice cream sandwich. Take a step back, ask yourself, is there some assumption I've been making as an app developer as to how users are using my app? And is there some way I can simplify it and make it feel more like an Android app, make it feel more at home, and in doing so, make it a bit more beautiful? All right, thank you.
Thank you, Trevor. So while Trevor's taking down his laptop and we're getting Jonathan Berry set up here, we do have a moment or two for a few questions. Does anybody have questions for Trevor about the Android universe? Yes. Oh, 1 second. Sure.
Maybe, yeah, depends on your question.
Is there a way right now, there's these apps called Mr. Phone, for example, that intercept the incoming call to check if the phone number is from a spammer.
Okay.
And that functionality doesn't work on my Sprint Android phone, mainly because Sprint is by far the worst of the telecom services, maybe. But is that an Android feature or a Sprint feature to turn off that ability?
So we have what we call the Android compatibility definition document and compatibility test suite. And this is the set of standards that tell device manufacturers what an Android device should behave like. And so this covers things like API calls, right? And so if there's some API call that's supposed to tell you what number is calling and that's not working, that means that most likely the device manufacturer made a change to the phone that for some reason was not covered by our test suite. And I can tell you right now that API call should be mentioned in our CDD, our compatibility definition. So I'd want to actually take a look at that app and see exactly what it's doing and why our test didn't catch that. So if you talk to me after the talk, I can take a look at it and try and get some more information and figure out what exactly is going on there. Android devices should always behave the same no matter who manufactured them. Even if they've gone and modified the UI, the API calls should always be identical. So, all right, any other questions? All right.
No more Android questions? All right, thank you so much, Trevor. So I also want to say to the live stream viewers out there, if you have questions, please feel free to plus mention me on Google+. Ask your questions during the talk, and I'll make sure that we get them answered on the live stream. I'm Timothy Jordan, by the way, and you can find me, of course, on Google+. And next up, we have Jonathan Barry, who's going to be talking about Hangout Apps and really the next generation of social applications.
Wait for the screen to load. How's everybody doing today?
Awesome. Good.
It's a little drier, right? we planned that on purpose.
Do we have any more Android questions while we're working this out? Come on. So who here has an Android device? You are my people. Who here doesn't have an Android device? You invert, probably, most likely, except for the guy who's actually texting on a non-Android device. Hi. So, no worries. And have y'all tried out the new ICS? Are you running ice cream sandwich? No?
Rocking.
Where do you try it? Trevor, where do they try it?
Next door, the Android house.
There you go.
Boom.
Are we ready?
All right, we're good to go.
All right.
So now we're here to talk about Hangout Apps. Hangout Apps being the next generation of social apps. My name is Jonathan Barry. I'm a developer advocate working on Google+ and Google+ Hangout Apps. I'll be joined shortly by some of my colleagues, Julia and Wolf. But before I begin, I want to talk a little bit about Hangouts. So in the audience, not the live stream, who's been in a Hangout? All right, awesome. Who's had Hangout with their family? Strangers? Bosses? All right. Drinking? No? OK, sorry. Hangouts are a new medium of communication. They're bringing people together in ways that telecommunication hasn't done in the past. It's a rich, immersive experience, multi-user, 10 people at a time, conversing, coming, going, meeting, shaking hands virtually. And it's actually a transformative medium. It's making things happen that was not possible before. I'll give you an example. Daria Musk was a small-time performer in the forest of Connecticut, doing random gigs in New York whenever she could. She first heard about Google+ and got on, saw a stream, and started meeting people. And then she saw Hangouts. And as a performer, she thought, you know what if I did a concert? I know there's not a lot of people on here yet. It's new, but let's just see what happens. I'll open it up to public and start singing. Within the first hour, she actually overloaded our systems. And we had to go behind the scenes and reconfigure, because there's such a interest in listening to Daria Musk perform. She went on for 6 hours, and from this small-town girl performing in New York's bars to a global success. Not only was she able to sing and engage with the audience, she can talk directly to the people in the Hangout. It's a way you can connect that you could never really connect before on a global stage. So it turns out Hangouts are really good at bringing people together. And when people come together, they want to laugh, they want to joke, they want to cry. but they also want to do stuff together. They want to collaborate. They want to build. They want to think. And that's where Hangout Apps come in. Hangout Apps allow third-party developers to create applications that are inside the Hangout experience that extend the conversation. Now, what makes Hangout Apps unique, just besides being inside of this video system, is the fact that they can be real-time, they're people-centric, and they have the access to the rich media that you can integrate with within your application. Now let me actually stop talking about Hangout Apps and start showing you Hangout Apps. So here I'm in the standard Hangout, and Wolf's is the big screen. Say hi, Wolf. And Julia is actually in the back.
Hi.
Wolf, I think you're on mute. So let me load up an app. So what you see here is a Hangout app running. Above the film strip and below the menu bar is the real estate for a Hangout app. Essentially, it's an iframe. You can do whatever you want with it. Of course, we have APIs that you can integrate, which I'll show in a second. Now, here's the idea we had. We're having a lot of fun at South by Southwest. We're working hard. And we decided, what can we do to stay longer at South by? So the film event is coming up. Let's submit a film into that. We're going to actually use the Hangouts and Hangout Apps to collaboratively build a film together so we can get it done in record time so we can actually party more. I mean, work more. So this is actually a Google Earth plugin. If you haven't seen it, it's a really cool plugin. It's using our 3D map data. I can zoom around the world. But for this movie, we need to first start with filming locations. So guys, do you have any ideas of where we should film?
Well, let's see. Coming from San Francisco, I say let's check that out.
I think we want to make a documentary about bears. So I'm going to look for Yellowstone Park.
Well, since I'm in Austin, I think I'm going to go there. So as you can see, Julia has already put some pins on. I just put a pin on. And what we're demonstrating is the social piece to Hangout Apps. This is a shared experience, and our applications take advantage of that and build that into. You'll also see that I can see what the pins they're doing. That's because we have an API that makes real-time apps possible. We call that the shared state. The shared state is pretty flexible, too. It's not just putting pins in the Google Earth. We can do a lot more with it. So to demonstrate, I'm going to actually start following Julia. And what I'm doing is moving in sync with what she's seeing on her laptop over there. So when she pans around, it moves my globe around. And this is not a screen share. This is the actual application updating in response to what she's doing. So to explain that a little bit further, I'm going to explain how the API works. Let me get out of full screen. Let me get out of full screen. There we go. Finally. All right. So this is a representation of the 3 different apps we have running on our respective machines. There's Julia, Wolf, and I. In the bottom, there's a box. This represents the shared state. It's kind of like a data store. And it's where we store the information that we pass around. So there's application code that calls the API on Julia's machine that says, hey, I'm at the US. This is the lat long positions. And the API passes that to our shared state. And it's stored there. Simple JavaScript call to send that over. You don't have to do crazy posts or deal with cross-browser issues. The API handles that for you. Now, almost instantly, the back end sends that information to all the app instances. So we have 3 here. If we had 10, all 10 people inside the Hangout would have that same information. Again, because it's our API, you don't have to build this real-time backend, a pub subsystem, dealing with set up backend servers for this piece. It just happens naturally. Also, you'll notice that it goes to Julia as well. It actually goes to everybody, so you don't have to deal with figuring out who sent what message. It just gets propagated. Now we just have a bit of application code that says, hey, Google Earth, go to that new location, and we're synchronized. And it's that simple. It's about 5 lines of code, 10 lines of code, all in JavaScript. So now back to our movie, because we really want to stay. I'm going to load up the second app that we put in. And that's... So guys, I don't think we have a good handle on where we're going to shoot. What can we do next?
We can maybe look for some costumes to use during this movie.
Awesome. So we're in this costume app, and it's going to help us try on different things. So the first thing you'll notice is I can pick any one of these guys and move my head around. This is kind of silly, but what it's doing is using our media APIs. So we have an overlay API that you can attach objects to and track head movements. I think Wolf is demonstrating that it pans with you. You can also resize, like Julia has a jumbo mustache. And you can also reposition. Now, these are not canned images. These are actually ones we've drawn and uploaded to the system and overlaid through the API. So you can do whatever your creativity lets you do. So to prove that, we can even draw an overlay. So forgive my artistic skills on a trackpad, but I'm going to draw a crown or a Bart Simpson hat, however you want to interpret it. And I'm going to wear it. Oh, that's... And we're just taking advantage of some of the HTML5 features that will be talked about a little bit later today. And it's powerful. And this is fun. This is a toy. But this actually has real-world applications. For example, if you're building a Hangout app that's a game, the high score might have a number that floats up, or a crown if they just beat the level. But if you're doing a productivity app and you want to identify who's the current color on the project plan, you can identify that with a little ID at the bottom. So I hate to be the bearer of bad news with all this fun, but I don't think we have budget or time to fly or build all these costumes. Is there any way we can stay at South by Southwest? Wolf, we can't hear you. What was that?
I think maybe we can do an animated movie. What do you think, Jonathan?
Ah, yeah. I'm pretty sure we built in animated features too.
Oh, that's great. That's a great idea. Okay.
Oh, there we are. Since I've been drinking a lot of cheap beer, I don't know about you guys, but PBR has been rolling deep for me. So I'm going to grab this PBR. Oh, wait a second. Ah, I got it. That's my animated character. I'm a hipster.
Oh man, but you've totally already sold out as a hipster. I mean, I gotta do that before they sold out with my blue pigtails and all.
Awesome. And Wolf is miming, but I think he wanted to be a bear from the beginning with the bear documentary. So, as you notice, the mouths are moving, and that's actually using our other audio-video APIs. So our animated characters responding to the volume of my voice. There's a simple callback API that triggers an event that animates that mouth. And we'll say something as if you're a mime again, and he's growling.
Growl.
All right, cool. I think we're going to have to do this animated film. We just don't have the time for it. Now, this has been a mix of useful with productivity, as in using Google Earth, as well as playfulness. We can go in either direction. You can build a full-fledged game. So as part of the film, we built this little game to represent combining all this stuff together. So let's go to the load this app. So here's the premise. We've been working really hard on these demos. We were coding late at the Googleplex, and we lost track of time. The doors are locked. We can't get out. And we really need to get to South by Southwest so I can give this talk. So we're going to try to figure out a way how we can get out of the Google headquarters and get to Austin. The whole purpose is to get into one of our self-driving cars. So I think I'll be the hipster, going with the theme. And here I am.
I think I'm gonna. I really dig these blue pigtails. I'm gonna go for the girl here.
Awesome.
And we know Wolf's love of bears, so... Oh, yep.
There you go.
It is.
So First thing I'm demonstrating here is that same shared state that we used to synchronize the globe. We're actually synchronizing our positions. So if you're sitting by Julia, you'd probably see me walking around, and she's actually moving her character around her virtual world. So to demonstrate that, we have a little debugger. Why don't you guys move around? So this information is what's being stored in the shared state. It's just strings with positions and some other metadata. And we've also carried over the audio API effect. So our mouths are still animated. And that we have a little debugger for that too. This represents the volume of my mic and the others' mics. And that's what our animated character is responding to. Again, that's just a simple hook into the API. Now, hey guys, do you have any ideas how we can get out of here?
Well, I've heard that we can map our way out of here, but we kind of need to know where we are, right?
Oh, let me go over to the kiosk. Do a little Google search. Boom. Whoa. Sensitive. I think we're in Mountain View, so let me look for Mountain View.
That sounds like a good start.
I'm feeling lucky. All right, so let me double click and zoom in, and it did.
Whoa.
Whoa. Whoa, Wolf, where'd you go? Boom. All right. I guess we found one way out.
Wolf has really good aim.
How are you in the Hangout, but also in the car? I don't know. We'll figure it out later.
You know, Jonathan, I'm really thirsty after that. That was really stressful. So I'm going to get a soda.
Sure. I'll grab a Mentos or something.
Yeah. Let's just take a break and figure out the next steps.
Hey, wait a second. Mentos? Diet Coke? Do you know what I'm thinking?
I think I'm thinking what you're thinking. I think I need to strap this absurdly large bottle of Diet Coke to my back. Like a rocket. Oh, yeah.
Bet you there'll be a lot of fuel in that. OK, so if I just splash in some Mentos.
Yep.
Boom! Wait. Are you there? Did you get in the car? Oh.
Whoa!
And that was fun.
Ow.
All right. So I'm the last man standing. I need to get out. How do I get out of here? There's got to be, I don't know, like a door or something that we don't know about.
I think that's a door probably should have been our first guess, but you think you should try it out?
Oh, yeah, that's right. I'll use the search. Let's see, door. I think we have one of those. Oh, that's great. Open Sesame. Did it work? I feel like I'm in the Twilight Zone. Oh, there we go. Now we're off to Austin. Dum dum dum. Okay. Well, that was fun, right? It was playful, and that shows some of the lighter sides of Hangout apps. But the Hangout apps can kind of go across the entire spectrum. Since it's really an iframe for you to work and integrate with into, as developers, you can do everything from productivity apps to music collaboration apps to research and discovery, but of course games too. The Hangout apps, because they're social, because they're real-time, and because they have access to this media that brings people together, it's a new generation of social apps. It's also a new frontier. We're in developer preview, and we're working our way towards out of that. So you can be first on board to bring your apps inside of a Hangout. And I think that's it. 1 second. Sorry, my final slide. I didn't go into any code today. So we have a code lab in the afternoon that you'll actually build. You sit down in 3 hours. You can, by the end, you should have our canned app and anything that you can come up with. We'll go through the nitty-gritty of code, answer questions, go through demos, and you'll become Hangout app ninjas. And then finally, our developer site has the documentation that you need to research if you're on the live stream, and that's developers.google.com/plus, as in the plus symbol, and Hangouts. And those are our Hangout Google Plus profile links. So you can circle us. Some more questions.
Great, thank you, Jonathan. And we're going to actually have YouTube come up and start plugging in their laptop while you bring down yours, and we answer a few questions. And we have a question from the internet first. A lot of people out there on the internet. And they would like to know, Jonathan, if they'll be able to change the whole layout of the Hangout window with the API.
Currently, we don't allow the ability to customize the layout. We just have APIs that detect things about the layout. So for example, if the chat pane is open, you have an API to know about that. Whether a user is using the app, so if they've switched off the app and they're just in the Hangout, you can detect things like that. That's a great feedback. We've heard that from a few people. And we're looking into ways to sort of customize the experience a little bit further.
Great. Do we have any questions from the audience? The live, in here, in person audience. I can see you in front of me. And I can start to pressure you for questions if you'd like. Ooh, a question over here.
We use a live stream a lot on the YouTube side. So one of the benefits of using live stream is being able to put in pre-rolls and mid-rolls. Is it possible to do the same on the Hangout side?
So pre-rolls and post-rolls. There are some APIs around muting somebody's video feed so you can go black. We also have APIs to do avatars, so static images. I don't know if we had it in this demo, but you can actually even animate the overlays. So you can display a roll on top of the video feed and gets propagated over for that particular person's feed. As part of the API, you can integrate with that. In terms of injecting right into the feed, the APIs are not there yet, but the overlays are certainly something you could do.
Cool. We have time for maybe one or two more questions if anybody's curious about Hangout applications or Hangouts in general, or what Jonathan's favorite restaurant in Texas is. No? What is your favorite restaurant in Texas?
I've only been to 2.
IHOP and?
Oh, 3. All right. The Moonshine one is over around the corner. Moonshiners. It's pretty good. All right. Thanks, everybody.
All right. Thank you. Oh, and I'm sorry, I didn't introduce you, which that's absurd of me.
I'm waiting for you.
It's ridiculous. You're going to be talking about YouTube APIs and video creation and curation. And some pretty cool new stuff. And you got a lot of friends with you, don't you?
Yes, I do have a lot of friends. Hi, everyone. My name is Jarek Wilkiewicz. I work for YouTube. And we'll be talking about mobile content curation and creation. Quick question, who in the audience develops mobile apps or has a mobile strategy? And who doesn't? OK, if you don't, then maybe you should go get a drink, because otherwise this might be quite interesting for you. So here's the agenda for today. We'll talk about the opportunity, what's happening in YouTube mobile, and then talk about creation and curation. So I will talk about APIs that we have to enable applications, then give you examples of these applications directly from our partners. And then we'll chat a little bit about consumption. Now, a warning, we have 9 demos, 20 minutes. 6 companies will be presenting. So this is going to be a lightning demo session. Hopefully, we'll try to maximize your time here. So forgive me if we are going super fast. But a lot of us will be hanging out later on today. So if you have any questions after this, please feel free to stop by. Before we start, I would like to give a shout out to people on live stream, YouTube live stream, since I know we have quite a few people watching as well. All right, so let's talk about the opportunity. So here's some stats that you might find interesting. We are having about 4 billion views on YouTube daily, and out of which in 2010, we had about 200 mobile views. Last year, you can think about how many we had, if you have any guesses, but actually the number was 600. So the mobile traffic has tripled. Similarly, for uploads, we're getting 60 hours of video uploaded to YouTube every minute, out of which 3 hours are coming from mobile devices. And that number is also growing very fast. So, which brings us to creation. We will actually have demos from Avid, WeVideo, who are here, and I'll show an application from Blix. First, let's start with the APIs. So if you are building mobile applications and you would like to incorporate video uploads to YouTube in your app, you need to think about authentication. We prefer OAuth 2. It's your friend. Client login works, but it's bad. It has a lot of issues. Connections will probably drop while you're uploading. We do support resumable uploads. So for those of you that have used it, should be pretty straightforward. If you haven't used it, it will allow you to pick up where you left off. Metadata is important, so make sure that your uploads actually have the metadata associated with it, because that helps us with video discovery and recommendation. You need a developer key from YouTube, because that'll help you analyze your uploads and get additional analytics on the actual performance of your application. And there's a little secret I would like to share with you that is frequently overlooked. If you need application-specific metadata included in your upload, you can actually use our developer tags feature to associate metadata that is only visible to your application. So next, we'll have a demo from WeVideo, one of our application YouTube API partners. I would like to invite John to come up here and then give a quick overview of the company as well as the demo. All right, go for it. And you have 2 minutes.
Right, 2 minutes. It's a lightning round.
Maybe 3.
Lightning round. Greetings, everybody. I'm John Canning with WeVideo. WeVideo is an online collaborative video editing platform, and I am allowed to put all those words together in one sentence. The reason is because that's exactly what we do. We are hosted in a browser, but now also running on our mobile phones. We're collaborative, so your friends can work together, share video from any part in the world, just like we saw earlier with the Google Plus example. We're doing it with video editing. And then having the real-time, one-touch export out to some of your favorite services. Ours happen to be YouTube. So let me show you a demo. That's a whole lot more meaningful than talking about it. So the first thing is, I've got my mobile phone. Now the nice thing is, what I'm going to do, I'm going to go ahead and capture a picture here of you fine people in the crowd. Lovely. Thank you. Thank you all for sitting still on your laptops. That's appreciated. And then I'm going to go ahead and upload my media right there. So what I'm doing is I'm now uploading it into a project that I created for everybody to share at South by Southwest. So that's one side of it. This is released now in the App Store, able to get it on your smartphones and start contributing and collecting. That's one side of it. The next side of it is let's edit it. So this is going to be coming soon. It's the tablet form of our editor. And so what you now have is all the stuff I've been uploading, all the stuff my friend Yostin has been uploading, but in an editor form. So I can sit there, go ahead and play with it. We can notice that, you know, unfortunately we don't have that exciting weather here, as she was commenting and earlier, freezing out there, the poor thing. But this is the power of the platform. So shooting on one platform, editing it on another, and sharing it with my friends. And then when I'm done, going ahead, one touch, pushing it to YouTube. So thank you very much. We're WeVideo. Thank you, Art.
Okay. Thank you, John. Now we'll have a demo from Avid. Who in the audience has heard about Avid? If you're doing video editing, yeah, fair amount of hands up. And I'd like to introduce Nikisha from Avid, who is going to tell us about the company and give us a quick demo. Where's that coming from? From our mic?
I'm going to very, very briefly show you how you do big screen streaming on your touchscreen using Avid Studio for iPad. Switch. There we go. Avid Studio for iPad is very intuitive. You just open up a new project. You don't even have to name it right away if you don't want to. I'm going to pull some clips from my video library down into the storyboard. I don't have to worry about the order that I put them in. It's pretty easy to rearrange once you're in the storyboard. There you go. I can also capture video and pictures from within the app. I'm going to put a still picture from the airplane yesterday down into the storyboard, and I can add a bit of Ken Burns effect on it by
have some transitions here, A to B. Also, I like the little crossfade there, so I'm going to put it in between my picture and video clips just to create smooth transitions. I can also put some standard title in here. This is one that I really like. So I'm going to put that at the end of our storyboard. Since we're talking about being your own personal VJ, I'm going to call it like it is, Wahoo YouTube. And there we go. I can also make that bigger. And wouldn't it be nice if that just was overlaid on top of that last clip, that last video clip? I'm going to go ahead and do that. It wouldn't be complete without music. My iTunes library is right here, so I can pull any track onto the timeline. You've got 3 channels there for audio, so if you wanted to do music and overdub, and if you wanted to put some Foley in there, however you want to do it. It's just as easy to edit the music channels as it is the video. I'm going to make a clean edit there, get rid of the excess, and bang, we have a video. There we go. It gets smoother as you render. We don't even have time for that today, but it is a very fast render. And once you're done with that, you're going to just put it right onto YouTube. Simple as it. There we go. And that is Avid Studio for iPad. Oh, there we go.
And if we can switch back to the projection screen. Okay, so last demo in this category, Vlix. It's a mobile app for smartphones that allows you to do video editing and special effects right there on your device. Vlix is an API partner of YouTube. They also have a web app on youtube.com/create. And let's switch to the iPad that I have here to give you a quick demo. Yeah, so the way it works, you can actually shoot a video right from the device, as you would expect. So I'm just going to go ahead and do it. Here, hello. There's the bar. How's it going? All right. And then I like the video, so I'm just going to go ahead and use it. We can add a couple of effects. So let me just improve the contrast on it. Maybe maybe I'll make it black and white right here, and then okay, can't see the demo. It's coming back. Okay. Maybe cable problem. Or should we switch to our backup? We can use the Elmo.
Okay, we can do that.
Yeah. Okay, so you guys can see that. Once I apply the effect, I can hit next and then share it to my social network, my YouTube account. So it's pretty straightforward. Okay, let's switch back to the presentation screen. So we will now talk about curation. curation is very important to us, and we have been adding a lot of API support to improve it. So if you're building a curation app, what's important is search capability, again, exposed via the APIs. You can find out what content is related to a given video that your user is playing. Watch later, you can discover what has been saved for watching. You can discover programmatically what has been watched. Trends, and there's more APIs coming, so if you're interested in this category, I'll be around later and tomorrow. Talk to me. And now we're going to have a couple of more demos, starting with Squirrel. So let's try this, and if not, we'll try.
Hi, so I'm Mark, this is Michael, we're co-founders of Squirrel. At Squirrel, trying to be the best place to discover and watch video on your mobile device. Right now we're available for the iPhone and the iPad. We've been featured in the new Noteworthy section of the App Store and achieved the rank of #6 in entertainment apps. We have we have millions and millions of videos in our system, thousands of different providers, thousands of feeds, hundreds of providers, and YouTube by far being the largest. Having said, yeah, can we switch? Having said all that, at the end of the day, what we're trying to do for our users is get them to videos that they care about. So how do we do that? At Squirrel, the first thing that you do when you come in to our app is we allow you to personalize your video experience. So you have the ability to select from all the providers that we have. These providers match up to certain given interest categories inside of Squirrel.
Can we switch to the overhead?
So, for example, we have technology, and Michael can go through and add in different providers that map to those interest categories. News, Wall Street Journal, CBS News, New York Times. It's basically building a personalized channel guide. And when he's done with that, he can get into our Fresh section. Give you a little tutorial on how to use the app, but you come into our Fresh section, which is the latest and greatest videos from all the providers you just selected, put into a dynamic playlist in that interest category. So you can he'll select from comedy, you can start watching video across all those different providers in a very nice lean back way. Inside of Squirrel, you can share videos across your different social networks. You can like the video in Squirrel. You can add to your queue to watch later. We also have a section called What's Hot. What's Hot is essentially trending video that's trending across all those different providers that we're tracking and all the different social networks. And finally, you're able to sign in or authenticate with your YouTube account, Netflix account, Twitter or Facebook. And if you sign in with your social networks, you're actually able to share video directly and message directly with your friends, as well as see their activity inside of Squirrel and use them as a jump-off point for video. So thank you for having us to YouTube. We really enjoy working with our team and their APIs.
All right. And I would like to invite Hannah from Link TV to talk about Link TV and give us a demo as well. Thanks, Hannah.
Thanks. Hey everyone, I'm from Link TV. Link TV is a national. I guess we're going to switch right to the demo. Okay, all right. Link TV is a national satellite TV station, about 33 million US households. We won a Peabody Award for curating and translating Middle Eastern news online and for broadcast. And so basically what we've done is we've done a bunch of digital projects, including a news website that takes this kind of curation and translation global and brings them all onto a website and into some mobile apps that I'm going to demo here that are still kind of in the prototyping stage. So what we do basically is about 80% of the content we curate is from YouTube and plays through the YouTube API. About 20% we produce ourselves. So we have environmental programming. We cover Asia, Asian bloggers, video bloggers. And then we perform natural language processing on YouTube videos to pull out automatically people's, places, organizations. We use Zamanta as a partner for that piece. And then we use that to do a live search to create related content on the fly. So I'm going to switch to the demo now. If you want to sign up for this app when it comes out in summer, you can go to linktvapps.com, and there's an invite list there. So here we have basically kind of your home screen, a curated list you can see from all sorts of different sources. We've got Al Jazeera English, ITN. We've got our own programming here through Earth Focus, Link Asia. We're also using these tags so that you can see when we offer the local perspective, which is kind of one of our unique offerings. So here you see the Iranian election from Press TV. So that's the Iranian state broadcaster and that we're offering. And then we have also, we're looking at the best raw video that you can see every day based on what's happening in the news. So I'm just going to jump into a video here. So here's, everyone knows about the Coney video. This is like the biggest thing right now. But you can see here we've got related information. You might not know who Coney is. So we do this in an automated way. So we're enhancing kind of YouTube's metadata by creating our own set of metadata. So Coney, Uganda, International Criminal Court, and then we also kind of bring in related content from other sources, articles, tweets, social media, and other videos related to this video. So this is kind of just the beginning. We also are building out map features, and there we go. There's kind of a preview of kind of what the map feature is going to look like, and you can check it out in summer. Thanks.
Okay, I'll just stand on the side.
Thank you. Is that yours?
Yeah.
Okay. You can thanks. Thanks, Hannah. Next up is business.me. It's a very interesting spin of curation.
Thank you. Okay, so we are business.me. We are a personalized business video network. We focus on videos about business topics, and we do three things. We do curation. We have an editorial team that selects the best business videos and organizes the videos in different sectors. We do personalization. We use LinkedIn to tailor-make your views depending on your professional interests and depending on your professional connections. And we promote the contribution of business videos by allowing users and companies to upload video or share video. So let's go to the demo of the mobile web app. It's a prototype. We have focused on the consumption of video. So you have several views here. The first one is the editorial picks, which is our curation effort, where we select the best videos from the web about business topics. Then you can go into your view, and you can sign in with LinkedIn. And that way, we can read your professional interest, also what your connections are watching in business.me or are sharing, and we can recommend videos according to that information. And you can also go to different sectors and browse and choose the sector you have interest, for example, development and design, and choose a video here from Google developers and watch video in the iPad. So that's business.me. It's a personalized business channel, and it's the best place to share and discover videos about business topics. Thank you.
Great pitch, short and sweet. Next up is the short form. And I have to say that short form has inspired the title of this talk, the VJ in your pocket. Jeremy and Alex.
Thanks, Yarek. Hey everybody, I'm Jeremy, a co-founder and lead developer at Shortform, and this is Alex, whose official title is Tallest Engineer. At Shortform, we're all about VJs and turning viewers into VJs and helping them create amazing channels. VJs curate channels on Shortform just by watching videos and clicking a button. They can then share those channels with their social networks via email and a variety of different ways. They can also embed their channels on their website with our embeddable widget. Viewers can then watch video channels at Shortform by clicking on the links that they get. The videos can come from YouTube, Hulu, and a variety of other sources. They can watch on all screens, including TV. We're on Google TV. We're a Spotlight app there. The desktop, obviously, and now tablet and mobile, which we're going to give you an early preview of today. The first step to bringing short form to mobile is providing a first-class viewing experience. So now, when mobile users click through short form links, they'll receive a mobile-optimized web application. This is a channel about one of my favorite subjects, my son. So videos will play in their embedded players in the page. As users scroll down the page, more videos will load, and they can see the whole channel. So the next step to bringing short form to mobile is going to be allowing curation directly from the mobile app. This is an early preview as well. People are going to be able to click on Add, choose a channel to put the video in, and they're done. They can then share those channels with their audience just by clicking on Share from the mobile app as well. And then viewers will get the first-class viewing experience. So I encourage all of you to go become VJs today. We're excited to announce that we've opened up a weekly VJ competition. So if your channel is one of the top-performing channels on the sites, you're eligible for cash prizes. So be heard, be a VJ. Thank you very much. Thanks, sir.
Okay, and then last but not least, I wanted to chat a little bit about video consumption and what we're doing in this area to enable applications. So all the apps that you have seen use our player or player API. And on mobile specifically, we have an iframe player, which allows you to actually embed the video playback in a native mobile application, so on Android in the web view, on iOS and UI web view. The object embed is another mechanism. It's a legacy mechanism. It still works. Specific to Safari, it's done through Safari plugin, mobile Safari. Obviously, you can launch the YouTube application on the mobile device if you wish. Typically, it comes pre-installed with the OS. And then there's more coming. We have a code lab at 3 p.m., so some of you in the audience have signed up for that code lab. The code lab is full, but it will actually be dedicated to improving the video playback experience for mobile. So I have two quick demos from two companies that couldn't be here today that really do a very interesting stuff when it comes to optimizing the playback experience. Showyo is one of them. It was ranked best social networking iPad app in the App Store. And then the next company is Nowbox, which is a personalized guide that really allows you to discover interesting content on YouTube and present your own subscriptions in a way that is very easy to consume. So let's switch to the demo. Starting with Showyo. So as you see, what Showyo does is presents videos on a wall that actually can be discovered by simply browsing it. So it's very interesting. It's a different type of user experience. They also have social features. They have featured links. You can discover what your friends have been watching through connections to social networks. And then the Nowbox user interface is also quite interesting. If any one of you has a cable box, this might look a little similar because the programming that you get from Nowbox resembles kind of the familiar layout. And based on your interest, they actually build a complete programming guide for you. So you can just sit back, relax, and watch the content that you are already subscribed to, or content that they have recommended. All right, and now we have run out of time. But we've done it, so thank you very much. That's Max demos.
Great, thank you. And do we have one or two questions about these YouTube APIs, or even any questions for any of the presenters that have come up and demoed with you? Yes, 1 second while I run out to you.
What inspired y'all to do all this? Because it's amazing. I mean, wow. Y'all should give yourselves a round of applause as well.
Well, I mean, thank you very much. I think the credit goes to the companies that presented. I mean, we merely provide the tools, but they are the ones that are innovating with it. So I would like to give a right applause to our presenters.
Any other questions? You got one more question. Hold on, let me get by you here.
Hey, cool. I love all the content curation. I was wondering if they had a quick second to talk about how their curation in their apps maybe integrates with YouTube's like already content curation with like subscriptions and stuff like that.
Yes. So you can integrate subscriptions programmatically. So if you subscribe to a channel in an app, that subscription actually is reflected in your YouTube subscriptions. As well as your actions, for example, liking a video, can also be integrated. So that actually represents a like on YouTube. So the API allows you that.
We actually have time for one more question if you have it. No? Okay. Well, then let's go right into Cloud Adventures. I like that title. We have Ayin and Michael here, and they're going to talk to you about spending your time on building your app, not the infrastructure.
Hi, everyone. Hello. Hi, everyone. I'm Ayin Valdez with our Cloud Developer Relation team, and Michael, and we're here to talk about Cloud Adventures. Does anyone here build apps today? A few people build apps. Does anyone use the cloud for apps? A couple of people. All right, well, this is great. So I'm going to tell you a little bit about the cloud, why you should care about it. So the overview of the talk is we're going to give a little bit of history about web application development, some of the challenges like 10 years ago and where we are today with App Engine and some of our other products. Talk a little bit about some of the new markets that are starting to take advantage of the cloud. You know, the web was sort of the primary market, but now we're seeing mobile, gaming, and big data start to be real industries that are taking advantage of the cloud. And then Michael's going to talk about BigQuery, big data, and some of the things we're doing there. So this is a picture of my life about 10 years ago when I was building web applications. I basically had this very complicated process of putting together the stack and figuring out how to launch an application. It took really, really a lot of time for me to like manage everything. And once I sort of figured out the stack and I actually started to write the application, and we had users, we actually had to figure out how to scale the application, make sure the application was running and people could actually get to our app. And spent a lot of time managing machines, figuring out how to get a database working, backing the database up, running the database, load, and then of course the users, which we were in the business of making our users happy. We actually did not spend a lot of time on our users. We spent most of our time managing our stack, and that was really sad. And things are very different today. So just sort of recap some of the problems when you're building large-scale web apps. One is that it's very difficult to get up and running quickly, and it's very difficult to iterate on your application and get it to the cloud. I mean, it used to take 3 months to get a stack ready up and running, and then pushing out builds was like a weekly to monthly process. Today, you can do that very quickly. The infrastructure costs were very painful, so managing the hardware, data centers, bandwidth, multi-homing to make sure that we were available if one of our data centers caught on fire, very painful. Backups, security, upgrades, all this just stuff we had to do just to make sure our app was running. And then databases were super expensive. So there's kind of two parts to app development. There's one serving the requests. The other part is actually persisting the data and making changes on your mutable data. And that was actually really difficult. So these were lots and lots of different problems. And this was sort of why App Engine was created, to sort of simplify this process. And App Engine's philosophy was to make it to make it easy to build applications, number one, easy to get started, easy to run and manage these applications. So once you've got it built and pushed, you want to make it really easy to kind of control it. And easy to scale. And this was really the key thing, was that all of that work on infrastructure was just to solve the scale problem. So we packaged all that together. And the other philosophy we have is it's free to get started and you pay for what you use. So it's really easy to get your app up and running. And it's not just for web serving, but also for data persistence. So today, App Engine runs on 3 languages. We have Python, Java, and Go. So it's pretty easy to get up and running. And I'm going to give you a quick demo to actually show you what it's like, how fast you can get an app running in the cloud. So I'm on Mac OS, and I have the App Engine launcher. You can go to appengine.google.com, download this in a few minutes. It runs on Mac OS, Linux, Windows. And I'm using the Python version. We're just going to create a quick app here. We're going to call this Ayin Demo. And the nice thing about this is it gives you a little starter project. And this starter project is basically your typical Hello world. There's a few files for configuration, but the main application here really is this Hello world. So let's just say Hello SXSW. And I'm able to then run my application on my machine in a disconnected state and test and build it. So here's my application, pretty easy. It's running locally on my machine. I can make changes and iterate. But now let's see what it takes to get this application into the cloud up and running. So we go back to our App Engine launcher, and we can click deploy. And what this is basically going to do is take my application, package up the files, and push it up to Google's cloud. So let's see, I've got my dashboard here, and let's take a look here. AyinDemoAppspot.com. And there's my application up and running in the cloud. So in literally a matter of seconds, you can take your application, on your code on your laptop, package it, and have it running in the cloud, and have millions of users hitting your application. So that is super, super easy. So that's a quick demo. Let's talk about some of the core features of App Engine. So in terms of serving web requests, we have sort of a few core features. We have front ends for short, bursty requests. We have back ends for long living requests, or maybe you want to run code in the background a lot. Task queues to be able to queue up work, and we have cron for scheduling. So there's some nice features built in. From the storage layer, we have a couple of different technologies. We have our data store, which is really our key value store basically in the cloud, very scalable. We have Cloud SQL, which is a MySQL in the cloud, and as well as a high-performance memcache layer to really aid performance. Services, we have a number of really powerful services. We have users API, mail API, image, URL fetch, MapReduce, a really cool one called traffic splitting, which actually lets you deploy multiple versions of your applications and do A/B testing really simply. So the key thing here is that all of these services, from the compute, storage, and users, mail, et cetera, these are all managed for you. These are building blocks that just run as a service. You don't have to configure, install software to make these things work. So let's talk a little bit about where we are today in the market. So App Engine today serves over 5 billion daily hits. We have over 1 million applications running on the platform and 150,000 active developers building. And you can see when we started out in 2008, the trajectory of this has just been sort of going up over time as we've added features. So it's a platform that you can launch your application and know that it's going to be there and run. So I wanted to give a quick example of what it was like to quickly launch and host and run an app in the cloud. So everyone here is probably, hopefully everyone here uses Google. And there's the turkey doodle, right? And so this was actually an idea of one of the engineers. He wanted to build this turkey doodle and launch it very quickly. And he didn't really know what tools to use. So he decided to try out App Engine and Go and put this turkey doodle together. And so he was able in 24 hours to basically create this doodle, test it, and launch it on the Google homepage. So this is kind of a cool little doodle. It's an interactive doodle. You can kind of click here and customize your turkey. And there's sort of a slot machine effect here. So you can get a random turkey doodle, and then you can, of course, link and share with your friends. So the point was this engineer was able to use the tools that are available to you, build this doodle, and launch it to millions of users in a day. And you have that same technology at your disposal, which is very cool. So quickly, a couple of other industries we talked about. Web was really a primary driver, a great use case, but now we have cloud-enabled mobile. So we have a massive number of mobile devices coming online. Everyone has a smartphone in their pocket. They're becoming internet-enabled. They're generating lots and lots of traffic. Apps now share state. They're no longer self-contained, so they're making API calls to backends and third-party apps. They're social graph enabled, right? You're pulling your friend network in and so forth. And of course, now there's video upload and download. So there's lots of information being generated. You need to serve this traffic. How do you actually do that if you're a mobile developer and you don't know anything about serving infrastructure? So that's where you can use something like App Engine. I wanted to give a quick story about a great case for this, which is Outfit 7. They build the Talking Tomcat apps and a bunch of apps you're probably familiar with. It's interesting because they have, I think, over 14 applications launched. They now have over 350 million downloads of their apps. Every day, over 1 million new users on mobile devices are installing this application. And they're available in 120 different countries. So that is a massive amount of scale. How do you actually make your app run? And they use App Engine as part of their infrastructure backend. Another great use case is Pulse Mobile. So this is another example of a mobile backend for Android, iOS, Kindle. Pulse is this news reading application. They use the Python runtime. They're serving thousands of queries per second. 100 million daily requests coming out of the platform, and it's very cost effective for them. So another example of a great mobile use case to power your application. Another really interesting market that's starting to take advantage of cloud as well is gaming. So I was just at the GDC conference, Game Developers Conference, and it was really fascinating to see all the developers out there, and cloud was a really big topic. So there's this really interesting shift of a new distribution model. Sort of the old world was the day when you had game cartridges or DVDs or CDs, and that's how you actually played games. You put these things in your gaming console on your desktop and you ran it. And we're now transitioning to a new world of gaming, I think, partly to the desktop, which is kind of fascinating. So Chrome has this thing called native client, where you can actually take your C, C++, or any native code, run it through the Chrome sandbox, and actually deliver those games into the browser. Very, very fascinating. There's also HTML5 native games, so you can run pretty powerful games in the browser alone. And then there's sort of all in the cloud, meaning gaming is fully running in the cloud. A great company that's actually doing this is OnLive, and they're essentially running the entire game on a server somewhere else, and they're just shipping the bits over the wire, so you can just play from any console. It's very, very, very cool. So how can App Engine help you with gaming? Well, there's a couple of things. All of these games have lots and lots of static assets, so big files that need to be served. data store for managing your scores, games, leaderboards, and so forth. So you need to be able to have a scalable database to handle that, as well as for HTML5 games, being able to serve up your web apps, HTML, JavaScript, and so forth. So just a couple quick examples of gamers that are taking advantage of this. Rovio built Angry Birds in collaboration with us. And it's a fully native web game, HTML5. It's using Play and Framework, Google Web Toolkit, Google Plus integration, and App Engine actually serve and run all of this in the cloud. So it's a great game. Check it out, chrome.angrybirds.com. Another really good game in the Chrome Web Store is Field Runners. So it's another example of a game. So just to sum up, and I'm going to hand off to Michael here in a second, think of using App Engine as it's a platform that's going to allow you to be nimble and focus on your application. It's perfect for web apps, games, and mobile. So it's great use cases. If you're building any of these things, really take a look at the cloud and App Engine. Focus on your application and not the infrastructure. Don't worry about managing it. You're not going to be an expert in it. Just let us do the heavy lifting for you. And so running the app is easy, but how do you fine-tune it, right? There's all this data being generated. Are your users happy? How can you take advantage of this? How can you help make your application better? And I think that's where all of this massive amount of data that's being generated, you need to sort of figure out how you can derive insight from this before it's too late. And that's where these big data technologies are really starting to come into play. And Michael's going to talk about big data. So thanks, guys.
Oh, great. Hey, everyone. Can you guys all hear me? Yeah? So yeah, thanks for being here. My name is Michael. I work with Ayin on the Cloud DevRel team. Okay, so if you've read a tech blog in the last 3 months, you've heard the term big data. It's a buzzword. It means two things when it's a buzzword. One, nobody knows what it is. And two, there's a lot of hype, right? But I think there's a lot of validity in using big data analytics for all kinds of applications. And I'm very passionate about this. The other cool thing about this sort of hype around big data is that there's a lot of cool tools coming out, things that we couldn't even imagine 2 years ago. And I'm going to talk about one of them today. Google BigQuery. But if you're interested in doing something with data analytics, I'm going to tell you a story. You probably know this story if you've already done this, and if you're thinking about getting into it, you're going to learn this story. So let's start with a single record. Here's a single record. It's easy to work with. It fits on your local workstation. You can develop with it without having to worry about extra hardware or extra infrastructure. And your manager, and in fact, this happened to me last week. My manager came up to me and said, we need to build a data visualization app based on some of the data you have. And I said, great, simple, no problem, right? You just build it. You can use the same kind of web stack you're normally used to, same tools on your workstation, you're fine. Well, it's a hit. Now you're a mobile gamer and you decide, well, I want to build a crowdsourced app that shows you which buildings are best suited for defending against zombie attacks or something, right? So you're using crowdsourced data, a lot of data. Now you have 1 million records. No, wait. Now you really have 1 million records, right? You have a lot of data. Now this is still okay. You can probably handle this on the normal application stack that you have, some of the software that you're using, you're used to. But there's going to be a point where those tools may not work, and that's when you hit something like 1 billion. And now you've got a big data problem. So what are some of the things that you might have to do when you get to billions of records, gigabytes and gigabytes? Well, maybe you shard your traditional MySQL database. Maybe you're buying new software. You're switching from one stack to another. You're going from a relational model to a NoSQL model. Or maybe you're pre-processing data for analytics. So you're running your traditional MySQL database overnight to get some kind of result. And then maybe you need more employee time, or you need more employees. And that's when things get a little crazy. Then your database starts looking like the Borg spaceship, and you've got terabytes of data, and then you're in real trouble, because then maybe you have to rethink your whole system. So let me tell you about scale, right? So as you move from paradigm to paradigm, what happens? Well, you can maybe predict the cost of new storage or instances or virtual machines. There may be a fixed cost there. But moving from gigabytes to terabytes, moving from paradigm to paradigm, I don't know. Maybe you don't know what it costs. It's hard to predict, right? And new expertise, new exploits, these are things that are hard to predict, right? So the total cost of your scale up is you don't know, right? And so when you don't know, you're not in the application business anymore. You're in the infrastructure business, right? And you're an application developer, right? You're making a game. You're making a crowdsourced mobile app, something like that. So you don't want to be in the infrastructure business. Google's been down this road too, right? When we were called Backrub and we were just a glimmer in a Stanford graduate student's eye, we had 26 million pages in our index, right? And then, but 2 years later, we had a billion. So our data just scaled enormously, and we had to come up with new tools to handle this. And then it quadrupled in the next couple of years, and then we added an image index. And then by, let's see, 2008, we hit 1 trillion, right? So we've been down this road. And now it's 2012. I think we're at a gazillion. I don't know what the number is. It's huge. Some huge number. So that brings us to Google BigQuery. Okay, so what is Google BigQuery? Google BigQuery is our tool for analyzing massive data sets. It uses a SQL-style language that you may already be used to. It makes it easy to write queries on this data. But the best part about it, as a developer, the thing I love is it's an API. It's a service. You make calls to it via API. You can use the programming language of your choice. It's a RESTful API. So we use this technology internally. We've written a few papers about it. Internally, we call it Dremel. And you can read the paper, the research paper we publish if you're interested. Without getting too technical, I know this is a lightning talk. I don't have a lot of time, but it's really great information. We basically store the data in a columnar format. And it helps us retrieve these kind of queries quickly. And so I'll show you a demo in just a second. One thing I want to tell you is the way you use it is that you take your data in CSV format and you send it to Google's cloud. Once in there, you can ingest it into the BigQuery data set, and then it allows you to run queries via API. So since this is an API, we're able to actually build a browser client. So when you sign up for BigQuery, you have access to a web browser tool. And that's actually built on top of the API. So it's kind of like a way for us to dog food our own technology. So I'll show you an example. So here's just a query window. This is a tool that lets you browse queries. You can see I've been playing with this today. There's a lot of queries. I'm going to show you how fast this thing is. This is pretty remarkable. We couldn't do a lot of the things at Google without the speed that this technology allows us to run queries with. The first thing I'm going to show you is a data set of all the revision history of Wikipedia up until about 2010, which is a lot of data. So let's count the records in this data set, and I'll give you a sense of how fast this tool is. So right now I'm running in 2 seconds. In 2 seconds, we return the result. I don't know if you can see it. Make it a little bigger. 330 million, records in that data. So in 2 seconds, we retrieved a count. Now, the fun thing to do with this data set is to see what were the most revised articles, right? Like which articles got the most attention. So let's do this query. This will tell us. Let's run that and see how long this takes. The most revised. Try to think about it before it's already done. George W. Bush. And I'm always fascinated by this, followed by World Wrestling Entertainment Employees pages. And I think I know why George W. Bush might be revised a lot. I wasn't sure about the World Wrestling thing. I think it's because there's a lot of fanboys and they like to add new stuff. The plot lines are going on. So I was looking at this data set and I thought, I want to know why these things are revised. So I started looking at the George W. Bush article, and I realized that when people revert due to vandalism, they have a comment in the revision history, reverted due to vandalism. So I wanted to say, well, how many articles were reverted due to vandalism or contained vandalism in the comments? And what's fun about BigQuery is it's so blazingly fast. You can run these ad hoc queries over and over. So let's see if I can find that one. Sorry, I have to zoom out a bit. Oh yeah, here we go. So let's see vandalism in the revision history comments. The answer may surprise you. 5 seconds, right? So we went through 313 million, 100 million rows in 5 seconds. Yes, George Bush, a lot of comments about vandalism. And then Wikipedia itself, and then Neopets, right? And so I gave this talk at another place, and I said, I would probably vandalize the Neopets Wikipedia article. And then Led Zeppelin, the controversial band Led Zeppelin, and then Adolf Hitler, right? So this is great, right? It just shows you the power of being able to query across these massive data sets. So I'm interested in Wikipedia. One of my coworkers at Google gave me access to a Wikipedia data dump of the actual text. This is just the revision history. And that's a very enormous data set. And I'm interested in bias language, right? So that's something I'm interested in, like studying. So I tried to write this web app. Let's see if this thing will work. This is the Wikipedia Weasel Text Finder. So weasel words in Wikipedia are words that have biased language or biased phrases, right? Here, let me actually make this a little bit bigger. Sorry about that. So language like without a doubt or it should be noted. So the Wikipedia editors consider this language to be indicative of bias. So I wanted to see what articles contain some of this language. So I wrote this app that actually scans the Wikipedia text and in seconds returns articles that contain some of this information. So here's many are of the opinion. Now let's just pick a random one like Menahem the Yassin. Now if you go to this site, and you can't really see it well, but it looks like somebody has already tagged this as a weasel word, or maybe this is an automated process. I don't actually know. It's a weasel word, so many of the opinion, biased language. So I wanted to go back and see, well, what about articles with it should be noted or without a doubt? Let's take a look. And now I'm scanning the entire Wikipedia corpus in seconds, right? So here we go. Here's a random sampling of articles that contain this biased language. Here's one. It should be noted. So I don't know what this airport is, but it should be noted, and it's not marked as weasel text. So imagine what you could do with this tool, right? You could do a daily scan and look for biased language in seconds, right? And you don't have to worry about the kind of crunching away, buying new servers, et cetera, et cetera. It's all an API, and it's very fast. So let's just recap this. So I want to get 2 points across to you. One, your data analysis needs should scale with your data, right? You shouldn't hop from paradigm to paradigm to paradigm. if you know you're going to scale up. Your cost and technology should be predictable. That's the thing a lot of people forget when they're doing big data, is they go from software to software, and it's great, and then they forget about the cost of switching, the cost of maintaining, the cost of hardware. And finally, don't build infrastructure. Build your app developers, right? So you can use this tool to build mobile, cool mobile games, crowdsourced tools, visualizations, dashboards. We have people using it to build game analytics technology. We have people doing things like with hotel and hospitality industry. Just amazing amounts of data and being able to do real-time dashboards with this tool. It's great. So, so that's all I have for this. I'm going to leave this up here. This presentation that Ian and I made is actually an App Engine app. And if you want to learn more, appengine.google.com is where you can go for App Engine, and developers.google.com/BigQuery, and that's how you can get a hold of us. And I think we have just enough time for questions.
Yes, questions about the cloud. We do actually have some time for a fair number of questions.
I'm sorry if I came in a little late for this. What's the pricing model for the for this?
Are you talking about the BigQuery pricing model?
The BigQuery.
Yeah.
Yep.
So so this actually we're still in limited preview, and we haven't launched an official pricing model yet. The one thing I can say is the cost of storing the data is very similar to Google Cloud Storage. So it's a very similar pricing model for that.
More questions from the live audience?
No?
No questions? All right. Oh, wait, we got some.
Last minute questions.
When do you expect the big data stuff to be launched?
This particular product is very soon, like maybe month or two.
Hey, I know a lot of times the first time you run a query, it's slow, and then later on, SQL cache catches up and it comes faster. Does that happen here? Do queries get faster the more you run them, or what kind of
This is
speed?
all. We don't have any caching on the server. You can do your own caching, and that's a strategy a lot of people use. But yeah, we don't do any. Anything else? I will say one last thing. If you're interested in using BigQuery, you can sign up for the limited preview and use it before we do the general launch.
More questions. Ooh, questions beget questions.
So is this useful both with structured data and unstructured data?
So this is for what we call semi-structured data. It's basically structured data. We support a limited amount of data types.
What about like full text search and those kind of things?
That's maybe an App Engine thing. I think
we
you
can do that with App Engine, so you can put your data into the data store, SQL, Cloud SQL, and you're able to run full text search operations on top of it.
There you go.
Any more last minute questions? Going once, going twice, going 1 to 100 times. All right, thank you. Guy around the HTML5 a lot. Paul is here to talk to you about just that.
There. Yeah. 1, 2, 3, 4. Beautiful. All right. Okay, I guess we'll get started. My name is Paul. I work on the Chrome team doing developer relations, and so I like to talk a lot about how to build web apps and what are the new things inside the browser that you get to play with. This talk in particular, we're going to talk about the new hot stuff and some of the cool features that you have. So these sort of things are available in Chrome Canary. So Chrome Canary is a daily build. You get an update about once a day. So it's all live, fresh, new stuff. Not too many bugs. It's pretty solid. I like to run it side by side with Stable. But a lot of these are also in other browsers too, like Firefox Nightly and Opera Next. So this is what we're going to talk about today. First, we're going to start off with some CSS, kind of what we have as far as styling. We're getting into some APIs that are appropriate for games. Then we're going to talk about, being a nice person to your users and like saving their battery. I'm plugged in, but my battery dies all the time. And so we're going to talk about how to be very conscientious about that, which I think is a good thing. And then I'm going to round up with some real-time voice and video stuff that I'm really quite excited about. All right, we're going to kick off, get right into it. We're going to talk about CSS regions. So CSS regions is a really powerful thing, and a lot of this work actually came from Adobe. So here we have a layout with just some lorem ipsum. But you see we have a column here, the text goes over to here, and we have kind of this area down here with a picture, and then again 2 columns down there. So semi-complicated layout, not too bad. But we're using regions. And so what that means is that we've defined these regions. I'm going to zoom out once more up here. OK, cool. So I have this, I'm defining my boxes and the geometry of my page. And then I have my content, which actually has all the paragraph text. And so that means that the paragraph text is just kind of filling from box to box. And so I'm going to add content editable. I'm just using the Chrome Dev Tools and adding content editable. This allows me to edit this text. And so I could just add in some Chrome hearts HTML5, something like that. And maybe we'll just paste it a bunch. And so you see it's actually pushing the text down into the next column. So this text is flowing from one to the next to the next. So I'm really excited about this because it basically allows for magazine-style layout, something that layout's always been a challenge. But regions gives us a lot of power. This right here is a prototype browser build from Adobe. And I'll show a few demos from this one. So this is similar to the last one. I just have these 3 boxes. I'm going to resize it. And you can see the text is flowing from one to the next to the next, just kind of filling up the space. This is all just purely defined in CSS. In addition to regions, the spec also captures exclusions. So this is, I want a circle and a heart, and I want my text to work around that. So I've defined my shapes. This is also completely dynamic, so I can just define this. The text is just working its way right around that. This is the debug view, kind of what I see what the actual shape is. And then I got 2 more for you on this one. Again, magazine-style layout, really gorgeous. And so we can just work against this shape, even add in a bit of just kind of tweaking that. And I like this one a lot. So here we have, let's see, I'm going to turn this off. Yes? OK, cool. So what I have on the bottom is actually the debug view turned on. So I do see the shape of my exclusion. And so as I slide this, the car enters, the mountain shifts, and we're also seeing all the text kind of just work its way around it. So this is really exciting stuff. Adobe and WebKit are working together on this, and it's available now in Chrome Canary. You just have to go into About Flags, where a lot of this stuff is. And inside About Flags, you'll find a lot of interesting experiments, and regions is one of the ones that we'll be covering today, but a bunch more stuff is in here. All right, filters. Now, SVG, if you've done SVG work, they've had filters for a long time, and we haven't had them in CSS. But you've probably wanted to, blur something, or like desaturate just a section of the page. Filters brings that, and we have it now. So I'll bring up this demo. Nice little seascape. Let's see. I'm not going to use that picture. We'll try that again. That's pretty good. So I have here this is like an image element, and I'll add some contrast. So this is just the CSS line that's making that change. There's drop shadow in filters. I can desaturate it, or of course we can blur it. Now I'm applying this just to an image element here, but this could be anything. This can be a video element. This can be a paragraph of text. This could be you've seen in other cases where like a modal pop-up will come out and then the entire background will be like semi-blurred. Like I think this is a common technique in Flex. You can do that, no problem. And this works just like any other CSS property. So I can use a CSS keyframe animation, kind of make your audience sick. I'm sorry about that. But there's a lot of power, and this is baked right into the platform. Oops. OK, good, cool. I want to give a shout out to navigator.connection. So this is an API where a lot of times you'll be building like a mobile app, and you want to know, it would be really handy if you knew exactly what sort of connection your user was on. You're going to send down high resolution imagery if you know they're on a fast connection. Otherwise, you're going to tone it down a notch. Maybe not even send any images at all, maybe just small sizes. So navigator.connection type has been available in Android for a while. It's not in iOS as of yet. They're still actually working out maybe a potential improvement to the spec. But this allows you to have that sort of control and act upon the network layer inside the browser. So on YouTube, in a little embed, you can click the full screen, and it goes full screen. But there's been no way to do that outside of Flash or other plugin content so far. So now we have a full screen API. This is implemented across modern browsers these days. So if we have, let's say, this video element, we're going to set up a little on-click element. And this is the main call right here, request full screen. And I'm just going to say I'd like to take this element and go full screen with it. So again, the beauty here is that it doesn't just work on videos or images. It can work on an entire section of DOM. So I'll take this video, and I'll start playing it. And so this is just like a div of sorts. And I'll just toggle full screen. And so we just take that entire div. We go full screen with it. We get that little notification pop up. And this is similar to the presentation mode. If you've ever gone manually full screen in Chrome, it's just that. But we've now triggered it with JavaScript. So we can give our users this option inside the app instead of asking someone to actually go up here and hit that. And the cool thing here is that we also know if the user is viewing inside full screen. And we can have contextual styling. So this right here, this is an iframe. And when I take this full screen, I can actually detect that it's now being shown in that full screen mode, and I can restyle it. So just here, it's a lame iframe. But when we go full screen, we kind of crank it up a notch. Pretty good. I mean, it's kind of ugly, actually, but you have the option. OK, cool. Pointer lock API is another API that is really exciting, especially when it comes to browser-based games. I guess quickly, let's say you're on a multi-monitor system. And if you want a game, if you want to run a game, you're going to want to run it full screen, like a first-person shooter. And when you bring your cursor to the edge, because you're like looking left or looking right, you don't want your cursor to go on to the next monitor. You want it to be stuck there, right? So the pointer lock API allows you to kind of define, this is the area in which I'm operating. So first you take it full screen. And then now my cursor is totally hidden. So the game can define its own cursor if it wants, but you're probably just going to use this for movement. And you can react, and you're kind of stuck in full screen until you want to get out of it, which is the behavior that you want when you're building a game. So this was another partnership. Some Google engineers got together with some Mozilla engineers, banged the spec out in like the course of 2 months, and it's implemented across both now. Another one that gaming community group got together on was the Gamepad API. And I'll just show this demo here. So we're going to show this with Firefox Nightly. But this is available in Chrome as well. So we have, this is just a 2D canvas game. And we're using an Xbox USB controller. It just plugs right into the machine. And essentially, Gamepad API can track any sort of adjustments to that control. So whether it's like a joystick with a lot of precision, or just up, down, or XB, XY, AB triggers, all those buttons are covered by the Gamepad API. So you can enable a more rich input method into your games. All right. Pause that and go forward. All right, so this, yeah, like I said, I think it's important to be nice. And one of the things being nice is recognizing kind of the context in which your users are looking at your content. Page Visibility API lets you do that. And so Page Visibility API basically says, is the user looking at this page? So I'll show the demo first. So cute little guy, HTML5 video, it's cool. If you see at the very top, we just wired it up so that we count how many seconds are passing by. But if I switch tabs, now it's immediately paused. I go back, it continues. So we're able to respond to the fact that we know, user's not looking here. We can change the behavior. And change the status. I think, if you're writing an IM client, user is idle, user is active, user is idle, user is active, or something. You might also, if you were polling the server for new messages or something, you're probably going to throttle it back. You don't need to be asking so much because you know they're not active. You know they're not there. So you have choices there. Another similar one is request animation frame. And request animation frame is a programmatic way of saying, I'm going to be putting things out. I'm going to be drawing things to the screen. But browser, you probably know what's best as far as hardware. And so why don't you take care of how exactly to schedule this? So there's two good reasons to use RAF, request animation frame. So this is a blog post over on the IE blog. They've implemented this in IE 10. And so right here it's showing on this top. Typically in animations, you'll use either a set timeout or a set interval and just bang it against 10 milliseconds. This is essentially, that's what this one is. Every 10 milliseconds, your app is going to generate a new frame of the game and try and send that out. But a monitor, like this monitor, this one, they refresh at 60 hertz. So you get a maximum of 60 frames per second. And if we can make sure that our game outputs a frame 60 times per second so that we can match and sync it up directly with the time that monitor is refreshing, that's ideal, right? So request animation frame allows us to do that. So we're just we got new content, browser, you take care of it, and it will keep the frame rate as high fidelity as possible. Otherwise, these red arrows indicate that you're actually missing frames. You're generating all this frame, and no one ever even sees it. The other good benefit is that just like Page Visibility API, request animation frame knows if you're looking at it. So here we have a WebGL particles demo. Love particle demos. Always looks good. Cool. Yes. All right, so what I'm going to do is, as you can imagine, this is probably a pretty intense demo. I'm going to bring up my task manager in Chrome and move that over a little bit more. All right. So in the task manager, we can kind of see how much memory is being consumed, the CPU. This one over here is the number of goats teleported. Not sure why that's in there, but it might be useful to you. But the thing that we're looking at right here is the CPU usage of particles morph. Right now, it looks like it's taking up 50%, decent amount. I'm going to switch back to the other tab. And this figure should drop. Yes. OK. So this is because the particle morph demo is using request animation frame. The browser's like, hey, you're not looking at it. I don't need to even send this out. This way, my battery's being conserved as much as possible, which I like. And then when I come back, I know that it's syncing up exactly with my screen refresh, so I'm getting the highest fidelity as possible. Sweet. A while ago, when HTML5 was getting a lot of attention, there was a lot of focus on a thing called the device tag. And this is what you think it is. It's getting the actual camera and microphone from your machine and having that as a first-class citizen in the browser. That's been changed. And so instead of the device tag, it's now called get user media. And this is essentially how it works. We have a video element function. And right over here, see if I can get that. It's somewhere. Is this S being passed into this callback. This S, oh, there it is, yeah, is a stream. And so first we're going to grab this video element, and then we're going to create an object URL out of the stream, and set that as the source of the video. So this just means get the camera, get the microphone, and just pipe it through to this video. So essentially what this looks like is this. Yes. All right, cool. So here's this is all built with JavaScript. Good, I like that. This is just so I can apply CSS filters, which I showed before, get a nice effect on there. And the guy who wrote this demo, I asked him for this feature a few days ago. I think it'll work. Sweet Polaroid effect where it has to fade in, but if you shake it, yes? Yeah! So you can actually, you can use accelerometer data. There's events that fire in MacBook Pros to respond to that, and you can be able to say, in this case, I want to speed up the rendering of that. But this is a really great API. I'm very happy to have it. Another one, you can mix. The thing I like about all these APIs is that they mix up and they mix well together. So we're taking the video, and now we're applying it frame by frame to a 2D canvas. And that means we can do something like, or just explode that video any way we want. We can apply any effects. So in this one, we are taking the video, and now we're piping it through to WebGL, because we're going to do a little bit more comprehensive changes. So we can do stuff like this. Anything you want. Whoa. I saw a tweet the other day. It was like, I don't care who you are, but like, put you in front of a camera doing these effects, and you will turn into a 5-year-old. And that is true. OK. I'm just going to move on. I'll be there all day. All right. This brings us to WebRTC. WebRTC is, well, OK. So you might be familiar with things like, let's see, Google Talk, G+ Hangouts. The live video is coming to a lot of things. You might be familiar with a small little blue icon where you video real-time chat with people over the internet. It's a good thing. Wouldn't it be nice if we had it baked into the browser? Yes. Yes, it would be. So WebRTC is an effort for that. So it's a plug-in-free way for doing real-time voice and video directly inside the browser, having a nice JavaScript API so that we can just wire it in. The really cool thing about this is that because the browser is handling it, it can add in a bunch of extra functionality that would be super hard for us as end developers to deal with. So like echo cancellation, noise reduction if it's loud in the back of the room, and it's like focusing on me. Automatic gain control to make sure that I'm not too loud or too quiet. If the network connection is bad, like I'm on a slow connection, but the person I'm talking to is on a fast connection, it's just going to work it out. Make sure that the fidelity of the video just kind of scales regardless. So there's a lot of good stuff kind of baked into it. And the cool thing is that WebRTC is a cross-vendor initiative. It's led by Google, but Mozilla and Opera are actively working on it. And so we have an implementation in Google Chrome now, but we're expecting to see it in some of these other browsers pretty soon. As far as how this works, it is peer-to-peer, but you do need to kind of handshake through a server. So that's this is the way that it kicks off. We set up a new peer connection through this server. This is like the protocol. And essentially, this should look familiar. We have a get user media again, where we're going to get our video and our audio, set up the stream, and hook that up. So we're really excited about this and think that not only WebRTC, but all these features give you a lot of functionality. So I want you to think about kind of the experiences that this allows you to provide, not just the features themselves, but combining them together, because I think it has some really good potential. A few resources that I would recommend. HTML5 Rocks is a Chrome developer relations site where we just publish a lot of this stuff. It very much focuses on kind of the edge of browser development. So what are the brand new things coming into Chrome and other browsers? A lot of very in-depth tutorials as well. Great content. I'm really, really happy with it. Check that out. HTML5 Please is a site that came out recently, and it is very much focused on like, I have, my people that come to my sites are real people with real browsers, and those browsers might be a little old. HTML5 Please is about making recommendations to you based on like, is it OK to implement this thing? What is the fallback story? Can I use a polyfill? So basically recommendations from people who have been there before on kind of the right way to handle every feature. And HTML5 Demos is another site where you'll find slide decks like this one and a lot of other demos as well. So I'd recommend that out. There are two sites. One is HTML5-demos. One is HTML5 Demos. Different sites, both good. And that's it for me. These slides are available at this case-sensitive link that you're welcome to, write down or something. It's not very friendly. I'm sorry. But yeah, thank you.
So it looks like we've got about 15 minutes for questions.
Awesome.
So there's plenty of time.
Yeah.
So if anybody has a question for this gentleman here, please shout it out. So the question for the internet audience was, does the pointer lock only work in full screen?
I was curious about this as well. I'm not sure. So I believe it does. No. It totally works outside of full screen. I'm not sure. This is the page. Luckily, MDN, Google has actually been contributing to MDN recently. And so I think, yeah, we contributed this page. And so in a lot of cases, the MDN actually has quite up-to-date information on not only what the compatibility story is and what browsers this is available in, but also how to use it. So check that out. Sir?
Is the video stuff just peer-to-peer, or could you do group stuff? Group chat?
OK, is the video stuff peer-to-peer, or can you do group stuff? So WebRTC, it can totally be group. You just need the server to set up the handshakes, but from there on, it can totally go scale to a group. Yeah. Very cool.
Can you stream video only to the server with WebRTC?
Can you stream video
only to the server?
Through the server?
Just to the server, though.
Oh.
Not to another peer.
So you're saying you want to do that, but without going directly peer-to-peer?
Right.
OK. That's a good question.
Can you repeat that question?
Yeah, so the question is, can you use WebRTC without going just peer-to-peer and instead proxy it through a server? So yeah, I haven't done it, but I don't see any reason why you can't just set up your peer connection essentially to the server instead. Yeah, you could totally manage that at the server level and just pass the connection right through to itself. So yeah.
Yeah.
Hey, what kind of API is it to kind of map what buttons people are pressing on a gamepad controller to like actual actions?
Yeah, so this is a tough one. Let's see, Rob Hawk's gamepad. Rob did an excellent post recently. I don't know if I'm going to be able to find this. Also, bring up this site right now. Please? Yes. Gamepad, yeah? OK, I can't find this other one. So basically, right now, what the Gamepad API is, it returns to you what the configuration is, the model, the configuration of the actual controller. And then it numbers all the inputs from like 1 to 30 or something, and then says that input 12 is now reporting this stream of events. There's 2 JavaScript libraries that try and work out differences between controllers. One of them is Gamepad.js, and this is actually made by Scott, who is the engineer who built the Gamepad implementation for Chrome. So it's a good guy to build a JavaScript library for it. And so yeah, it tries to smooth over the differences. So with different gamepads, you will get kind of different mappings. And so you essentially need a dictionary lookup like this to normalize. They're trying to figure out a better way to handle that, but right now you're essentially looking at one of these libraries. But these are well tested and kind of where the entire community is focusing its effort. So it's a good setup to have.
More questions.
Does that CSS drop shadow work with alpha channels?
Work with alpha changes?
Alpha channels.
Channels? Like you have an alpha channel on... Ah, well, So, yeah, there's a very large debate regarding the sorts of shadows that are available. And if I have like an SVG shape or some non-rectangle, if I have, not text has its own shadow. Yeah, so there's been a big, so I can't cut out a circle out of this unless I used clip. No, clip wouldn't work.
Like just a PNG.
Yeah, so PNG would not work. So since, so the filters actually, let's see, FXTF filters. So the spec actually comes over here from the filter effects cross-functional group. And this is basically a collaboration of people who have been working on SVG and then people in the CSS land. And so all the filters, while I was showing kind of the shorthand filters of these guys, it actually takes in a lot of these primitives. Those are just shorthand for mixing up the filter primitives. And all of these come directly from SVG. And because they come from SVG, SVG is all about custom shapes. And so while I can't bring up a demo that uses a custom shape in these filters, I have no doubt that it works. We also, there is hardware acceleration for, I think we landed full hardware acceleration for all these filters in Canary. So that just means they're faster, which is a good thing.
Quick question on, it seems like you guys have implemented everything that Flash did. Is there anything left? Like, I feel like you guys...
Yeah, good question. I was curious about this as well. What is left? There are a lot of wishes. I think part of it is building on top of things. We just finished off mutation observers, which is essentially an iteration on mutation events, but they're far more performant. So with mutation events, you would subscribe to like DOM subtree modified, and it would tell you if anything in the DOM had changed. People use this all the time for Chrome extensions, for Grease Monkey scripts, when you're hooking into a third-party web page and you want to know if someone clicked the new tweet button because you're going to add some part of the UI to it. But these things are very not performing at all. Mutation observers are a better way of tracking these changes, and you get your results about 500. It's like 500 times more performant than the other. So in some cases, it's things like that. Other cases, I've heard I want Photoshop's blend modes, like darker and multiply against DOM. So like this div, I want multiply against this other div. Filters might get us part of the way there. But yeah, there's a lot coming in CSS in particular that I'm happy about. So like CSS as a language is limited. Mix-ins, so things that you might be familiar with from Sass and less than the other preprocessors of variables, mix-ins, selector nesting. There's specs for all these things, and some of it's starting to land in Canary. So one in CSS variables in particular. We do have a spec for it that Tab Atkins, who's actually here at South by, is working on. And yeah, here it is. And our engineering team is actually implementing this like as we speak. So we're going to be expecting to see some of this stuff just happening for real. And I'm excited, especially in the CSS land. Layout, we have grid layout, the brand new Flexbox, the regions that I showed. I would expect the DOM to be better as well. Right now, the DOM, like people use jQuery because DOM APIs are annoying. And I hope we're going to see that improve. There's a lot of people that want to make that better and make that more performant. Any other questions? No? Cool. Well, again, HTML5 rocks. Good stuff. And if you have any more questions, feel free to tweet at me or hit me on G+. I do post a lot of really cool stuff about HTML5y stuff, Chrome DevTools on Google+. Try and look it up via Twitter when I can. So good things. Check that out. So thank you, guys.
Thank
Appreciate
you, Paul. All right, and coming up to the stage, we have both Josh and Chris. And they're going to be talking about making your maps beautiful and interactive. I'd also like to remind you, if you want to see this after we're done today, we're recording this whole thing, and it's going to be available on the Google Developers YouTube channel page. So you can just do a quick search for that and get all of these sessions on video at home later. You know, maybe there's something you missed or you wanted an instant replay of one of Paul's slides. You can get all that.
People to settle?
Yeah, we'll give you a couple minutes to settle. We do have this one last session about maps. If you're in the back and you'd like a seat, we have some lovely seats up here. They're green, they're triangular, and they make me feel a little bit like I'm in elementary school. You see these chairs? These are cool. A little desk would be great, but you see how they have the hole in the back? Remember that from school? I don't know why that hole's there. Gum. So you can put the gum through there. So yeah, please do come on up and grab a seat. We do have some more seats available, and why don't you guys go ahead and take it away?
Yeah. Josh, do you want to come over here? Yep. Should I come over there? All right. I'm going to make a run for it. Sorry for this noise that's about to happen. Made it. We have some speaker effect. All right. Should we get started?
Yeah, let's get started.
Okay, hi everybody. So my name is Josh. This is Chris. We're on the Maps Developer Relations team.
Yep, we're going to talk today about beautiful maps. So making your geographic information beautiful and interactive. And so we're going to be showing some cool things that we've been working on, various Google APIs, a whole bunch of awesome HTML5 stuff. So let's give a bit of context to this talk.
Yep, here we have a very early map, Mayan. A lot of things you notice about it, a little different from the modern web maps. It's smaller. It has a legend at the top. It has none of the HTML5 stuff that Paul was going over. And our intent is to try to fix some of these things in future slides, but it's good to see where maps started.
Not very interactive.
Not very. So here we get a little bit interactive. This is about 15 years ago, state-of-the-art GIS system. Lots of data, people starting to make kind of these interactive maps where you could toggle lots of checkboxes.
The sad thing here is you have to press radio buttons to navigate the world.
And press redraw to redraw it. And each map tile is dynamically done for you, custom. But it was a bit slow, not super user-friendly.
Unfortunately, some people still make maps like this.
Yes, they do. So things got better. We got all the important countries on an early Google map. The key here is we pre-rendered the tiles in advance. And so I came up with this idea of this slippy map where you could scroll around and everything's kind of instantaneous feeling and just really dynamic, nice feel.
So you're not loading everything as you try to look around.
Yeah, so it's not super custom. We've decided in advance what the look and feel is, but you get this really nice interaction. So this is kind of the start of the new age of interactive maps, not that long ago. Here we have added some more countries and some more data, and tons of stuff on these map tiles. So these map tiles seem like they're pre-rendered, but actually there's a lot of interesting customizations you can do with them when you go to the Google Maps, and that's what we're going to take a look at here. Little did you know, perhaps.
So this is styled maps. This
was launched at Google I/O in 2010. And so it basically allows you to change the colors and display of all the map features. So here we've got beautiful landscape as black, roads as pink. This is one of my favorite styles, by the way.
He's a professional cartographer. That's why we hired him.
By trade.
But you switch back and forth between the map and the other version there. Yeah. And you can see that what we're actually doing is we're rendering these tiles kind of dynamically for any style that you want to have. Maybe show them the label style.
So
and the idea, oh, go ahead.
This is one of my favorite maps. It's a map without a map. They're just labels.
Yeah,
so
you zoom in and out.
Experiment.
Yeah, so the idea here is we can provide a really custom experience for you. But again, this is not your data. It's a story you can, or a backdrop you can use to tell your story with your data. So be sure you always kind of customize the background and that your sort of pre-tiled images are telling your story you want.
So you can use this to sort of bring your data alive. So if you're displaying stuff on a Google map, you might want to remove roads if they're not so important for your data. It's really cool.
Yeah, our base map is really designed, the story we're trying to tell, which may not be the exact same story you're trying to tell, like where all the freeways are, where all the public transit. But anyway, let's get to your data, which is what the talk's about. So here's a bunch of trees mapped in San Francisco, a couple 100,000 trees. There's lots of it, and this is, I guess, green dot fever, variety of the red dot fever that comes around when you're trying to, man, I have a lot of data, how am I going to put it on the map? And the classic way of doing this, since browsers until very recently could only handle maybe a few hundred, a few thousand points, is I'm going to have to take this data, put it on a server, render up my own tiles, and overlay those tiles on top of the map.
It's pretty hard.
Yeah,
it's a lot of work.
There's a big stack of things you have to take care of and think about. We have some tools to make this easy, but this is kind of what you're seeing here. These are rendered tiles, and then we just display these PNGs on top of the map.
They move with the map, of course.
Yeah, you can click on them and get some information back, kind of makes a call to the server and says what's here, and here's a tree and the species and whatnot. But your interaction's limited, and again, you sort of have to get it all through this workflow of rendering tiles. So what if you could actually just use JavaScript to put your data on top of the map?
So this is one of the solutions to this big data problem. It's called clustering. Unfortunately, it scales only up to maybe tens of thousands of points, something like that.
Yeah.
It's quite pretty.
And we can't display all 10,000 either, so we got to only display a few hundred at a time. Here, there's much less than that.
You sort of get it's sort of a cheap heat map, so you sort of get a sense of where all the points are.
Now, there's some stories that this is actually conducive to, so it's actually sometimes great to do a marker cluster for certain types of stories. But it's just important to remember the inherent limitation here is we can't be displaying, a million points in JavaScript on the browser. So this is one of the techniques to get around that.
As you zoom in, you get individual points, so you can click on them, whatever you want.
So keep in mind the marker cluster, you have a bunch, a few thousand points, you want to display them on a map. And then we should look at what the future holds, or the current now.
So this is an experiment I did, it would have been a few months ago now, just to see how many points I could throw at the browser. So these are 10,000 crimes in San Francisco over a 1-month period.
Very safe city.
Yep. And I decided, I just want to render all of these and see the places I should avoid when I'm visiting the city. So I'm coloring different types of crime with different colors. And as they are drawn on top of each other, they stack up. So you can sort of see hot spots of crime activity.
And the important bit here is instead of rendering these as tiles in an overlay, we're just throwing all the vector data down to the browser displaying these using Canvas. So finally, HTML5 has arrived.
Yeah.
Canvas.
So as I zoom in, they just keep rendering.
OK. All right. So here is a bit of a morbid map. This is the last 7 to 10 years of traffic fatalities in the United States. We're looking at about, go ahead and type fatals into the box there, and maybe zoom in somewhere. What we're looking at here is about, I think, 300,000 accidents or so. Yeah, maybe just, 278,000. And if you zoom in somewhere else, there's a couple interesting things to note. Maybe zoom into Austin. Yeah, there we go. So here's a bunch of points, and what you can see is about 700 accidents or so. Go ahead and type in, or move the slider, the size of the slider. One of the things you'll notice as you zoom in and out, you can change it to a really gruesome looking map with a lot of accidents, or maybe something a little more subtle, you're trying to get a different point across. We can style them according to different colors, and I'm kind of contradicting what I said, you can't get a lot of points in here. And what we're doing here is we're using WebGL to render in the graphics shader a lot and a lot of data. We can render a significant amount.
Millions.
Yeah, many millions. So it's pretty exciting. It's kind of a new world where we can send the vector data over and actually render these in the browser and actually start to run different types of analysis or filtering. So a really simple example, go ahead and hit that filter there. You've probably heard most accidents happen close to home. So I've just got a filter that runs on the distance between where the accident occurred and where that car driver is registered. So you can see as you drag it all the way up to 100, say, most of the accidents go away. Most people's accidents occur within less than 100 kilometers, 60 miles or so of their house. So maybe zoom out to Florida, say.
I don't know where that is.
There it is, in the bottom right. That's why we have, so we have this Places API drop down for people like this. It's pretty good. You just type in whatever you want, it takes you there. Yeah, so you can see there's a lot of accidents that happened. It's crazy. More than 100 miles away from home. Probably a lot of people there as tourists. So you can kind of get an idea. Here's a tourist spot. Everyone goes there, has an accident. The locals still have a lot of accidents. But there's still plenty left without. Whereas you go to a city, say Sacramento, San Francisco, and you drag that away, you'll see almost all the accidents. Hey, maybe try it, yeah, or Austin. Most of the accidents happen. Where'd they go?
There's none.
Oh. Make it a little bigger. Maybe that data didn't load.
There.
Interesting. There we go. Yeah. So anyway, you get the general idea here, which is I can throw a lot of points, do cool techniques, kind of like Paul was showing, animate these, filter them, style them based on some attributes, and at about 60 frames a second get some pretty dynamic results. So let's scoot over to another quick example using the exact same stack. And what's cool
very
about
bloody map.
Yeah, not accidents. This is just census blocks sized by population. It's a little bit better. So if you zoom out here, just a couple zoom outs, you can see I got millions of census blocks here. That's good. And you can drag the filter if you want. And it's not especially amazing map, except to show off I can display millions and millions of points in WebGL on top of a map pretty easily. And this is being run through App Engine and Cloud SQL. So no special spatial database or anything. Just toss it into MySQL, stream it over in binary format directly to the graphics card. And then I can work with this in JavaScript to style and do analysis. So pretty cool stuff when you have really big data that you want to have an interactive feel with.
Yeah, on the topic of big data.
Yeah.
I say data, actually. So this is a data set that I've been playing around with for the last few weeks. It's really awesome. You should check it out if you're interested in this kind of stuff. It's 25,000 cab trips in the San Francisco area over a week period. So you've got here the cab ID, the time, and the location of the cab at that time. So the cab ID is useful because you can string together a whole bunch of these points and figure out the path of a particular cab. So this equates to over 1 million points. So similar in vein to Josh's visualization, we can just display them all at once. So of course, all of these points, 1 million points all stacked on top of each other, it doesn't look great. So each point I've got very small amount of opacity, so they sort of stack up. And you can immediately see the most traveled streets. So just for a moment, imagine that the base map wasn't here. You'd sort of be able to get a sense of the layout of the San Francisco city, which is pretty cool just from this raw data. And then we can do something like take a selection of that data. So here I'm taking a slice of time, so from 4 p.m. on Sunday to 4:08. And you can just see the trail of that particular car.
Maybe zoom it in a bit there, yeah.
Yeah, so this is sort of interesting, but you can't get a sense of the direction that the car's traveling in. So we can apply some techniques, color and scale, to sort of show a trail behind the cab's current position at the end of that time slice. This is sort of cool. You get a sense of direction, and then we can do some really cool things like animate through, and you really get a sense of the flow of the traffic. And so just by moving the slice of time slowly, so we're doing about 5 minutes of time every second, something like that. You sort of get a sense of flow. And if I did this through the whole data set, you'd cycle through the days of the week and be able to see the busy and the quiet periods. That's sort of cool, but let's do some more interesting things, such as coloring. So here I've applied a color to each point, and it's the speed of the car at that point in time. So I've used the cab ID to figure out where it's been traveling, the speed. And so this is sort of cool. Just by plotting all of these points, you get a sense of where the traffic in the city is. And if I just zoom in, it sort of fades out. And we can provide a tool like this to sort of bump up the opacity so you can really start to explore the data set. And so the interesting thing that you might see here is that around the Market Street area, downtown, the GPS is really noisy. So you can sort of see, as opposed to really straight streets, you've got all this sort of fuzzy points.
Tall buildings are not good for GPS, turns out.
Yeah, apparently cars can't drive through buildings. So we can combine these techniques to sort of get a colored squiggle moving around the screen, which I thought was pretty cool. When I first did this, I sort of just animated through it and stared at it for 5 minutes, as I will do now for 5 minutes.
Can you talk a little bit about what your data set actually looks like to power that?
Yeah, sure. Let's just look at the next thing first. So this is a 1 hour slice of time. And this is great because you can just scroll through and get a sense of the traffic flows in that hour. So you see it gets really quiet around 4 a.m. And as I keep scrolling through, you sort of see the sort of more macro level of the flows of traffic throughout the week. And it gets really busy on Friday night. And you can see the traffic starts to get pretty bad around 5 p.m. You know, as people are heading out to dinner and whatnot. And then Saturday night gets really busy again. And you can do cool things like if we just go ahead and display the whole data set, we can go and zoom in. So this area looks a bit funny. So it's sort of interesting looking for these red areas where cars tend to stop. And so another cool one's down here near the airport, some sort of waiting bay or something like that. It's sort of cool. And this is really awesome because you can zoom down into a particular point, which is sort of amazing.
Let's hop back to that data set for the guy's question, because what's I think so incredible about this is it's really just some straight GPS lat long times, and then from throwing that directly at the browser, we can create these pretty incredible dynamic interactive tools.
Yeah.
Rather than having to render some preset tiles in advance and here's the story and here's the map, which is great and fine, we can really start to play with it.
The other thing we didn't mention was we're using technologies like WebSockets to stream some of the data down. So like for the example where I showed a small slice of time, you could stream just that data down to the client. They can start looking at it you know, in hundreds of milliseconds as opposed to loading the full data set. Yeah, it's kind of cool. Or you could load, you know, just some portion of the map that they're looking at, something like that. Yeah.
Yeah. You want to show the heat map?
Yeah. So another visualization of this data set. Basically just a heat map. So a heat map's really an intensity map. So we can see the most traveled roads, which are in red, and it sort of fades out to blue. And all of this is being rendered using WebGL as well. So it's quite fast. We've got 500,000 points here. I've just taken half of the data set. And you sort of see this really blurry area around Market Street again, which is interesting. But this is a really good way to see the most frequently traveled roads. And you sort of get a sense of where they're stopping for traffic lights and taking off. You sort of see a sort of triangle pattern at intersections, which I think is interesting.
Yeah, yeah. And I think, again, the main story here is problems that used to be really hard. Displaying a heat map, you had to set up all this infrastructure, you have to get your points and type of geospatial database, you have to render some tiles, and then boom, you have a static heat map. Now we can just get the raw data and let users sort of see the story that they want to see.
You can start to explore and look at what you want to look at. Great.
Yep. So I think that's this. Oh yeah, what should you do if you would like to do this type of thing? So as kind of start out at the beginning here, just a quick recap. Not all the way the Mayan style, but if you want to start using some techniques to make pretty maps, use our styled maps. Make sure your background, like you noticed in these demos, a nice faded background lets you tell your story nicely on top. Maybe the story you have to tell, you want some really vibrant colors, you can use that beautiful example.
Yeah, I have a sweet video of a Christmas styled map, all green and red and white.
You can imagine how pretty that would look. And yeah, so style map's really good. Use that for the background. You got some, couple thousand points. Maybe you want to cluster them. It's a good technique for the story, depending on different stories you have. Daughter, it's open source library you can look for. That's just a canvas duplication. So a lot of computers don't have WebGL ready. You maybe want to display a few tens of thousands of points. We can get that into nice canvas. It's widely supported and looks pretty good. Put your data up on some App Engine, Cloud SQL type of thing if you want, and then just stream it down with WebSockets or what have you. You've got all the HTML5 stuff we covered.
Yeah, so all of those links are down at that goo.gl short link, which will also be on the next slide. Yeah, thanks for coming.
All right.
And drive safely.
Yeah, indeed. So looks like we have about 5-7 minutes for questions. Is that right, Timothy?
You do have time for questions.
That's what I like to hear.
How many can we get?
Yeah.
I can always rely on this guy for a question.
Uh-oh.
Oh.
Hey, Cole, you mentioned kind of briefly the limit between SVG and when you start using WebGL. I'd like to know more about where that limit actually is, and then maybe even what, if any, is the upper limit of WebGL for the number of points you can show.
Yeah, so we actually didn't do anything with SVG, and I haven't done much work with SVG, but I think for this kind of work, Canvas 2D is faster.
You tend to notice a bit of a panning delay on the redraw when you're working with SVG, so it kind of renders quickly and you have instant CSS action on it, which is great, but it has some other drawbacks, and we kind of prefer going with the Canvas route. But really important question, which is how far can you get? 5,000, 10,000, 15,000 on Canvas, and it really is up to the person and their browser.
And their computer, yeah.
Yeah, exactly. So most modern browsers, you could get 20,000 points, no problem, probably on Canvas. But maybe an older browser, you'd have some.
So we sort of say, so we actually render Google map markers in Canvas, and we sort of say tens of thousands on modern browsers, and non-modern like thousands, something like that.
Yeah. And it's really kind of the same for WebGL. Depends a bunch on your hardware, on your graphics card. The main limiting factor we've noticed in WebGL now is the bottleneck is kind of the bandwidth to get all the data over. And there's some interesting things we're thinking about to make that. So I didn't really show you this part, but for example, in the fatality demo, there's like thousands of attributes. You can get all these tables are joined. I have a really simple API. I just get only those attributes that I want, and then bring those ones over. And so there's some techniques you can use to overcome that bottleneck. And the WebSockets, just getting the subset you want.
So even though you can bring big data into the client, you might not necessarily want to take all of it. There's definitely a case for taking slices of it.
Yeah, but definitely, a million plus points we've been showing, and pretty snappy, no problem here. So.
And heat maps are pretty intensive to generate as well. Yeah, so it's cool stuff. Yep, down here.
Yeah, I was just wondering if the API would include a fallback for less modern browsers for those features, like for WebGL and Canvas.
Right. So everything we've shown here isn't in the API itself. It's just sort of our experiments.
So as a developer, you would potentially check to see if the person had WebGL. If so, give them one experience, and kind of have your own series of fallbacks, which is a pretty good technique to have generally. Yeah, exactly.
So maybe if they don't have WebGL, you don't have these cool sliders. You just give them the tiles to look at. Yeah.
Additional questions?
This might be a little bit of a segue, but so I saw you guys did a lot of stuff with the map itself, but one of the pain points that I found is the map bubble. Were there any developments made in making it easier for developers to customize the map bubble itself?
Yeah, there's a couple open source libraries that sort of re-implement a nice looking bubble. Info Bubble's one of them that's really customizable. You can use CSS to style it. Yeah, check that out.
More questions? No? Is that it?
All right.
Is there anything else you guys want to say before we go?
No, we'll be around here for a little while if you want to come up and chat. Yeah, drive home safe and play with WebGL.
Yeah.
Thanks, guys.
Thank you. Thanks.
All right, so just a few announcements for you before we get going. Thank you, of course, to all of our speakers for the excellent material that they presented. I'd also like to thank NewTek for bringing in that really cool TriCaster rig and making our web stream look absolutely fantastic. We do have a hot dog cart out front, so if you're hungry, please do grab some food. We also have, what's that? Yeah, sorry to the live stream. No hot dogs for you. We do have Code Labs later today, so please be sure to check out that events URL. Just search for South by Southwest Google, and you'll get to our events URL with speakers where we're speaking all around South by, and also come back for these Code Labs. It's a really great chance to get sort of one-on-one attention to do some cool stuff with the APIs. And those are at 3 p.m. in this house. Anything else? I have cue cards. They're human cue cards. It's really great. But thank you so much and have a great time at South by, and do try and stay dry. Bye now.